Yes,
Good afternoon. Good afternoon, Dr. Dadej. Shall we start?
Yes, sir.
Okay. So I welcome Dr. Pankaj Dadej for this technical session S3. He is working with SKIT Institute, Jaipur, Rajasthan. And Dr. Dadej, thank you very much for sparing your valuable time for us.
Thank you, sir.
And I hand over this session to you to chair the session. We have 5 papers in this session. Yes. We have 5 papers in this session. So I hand over this session to you, sir. You may proceed.
Yes, good afternoon all. So first paper ID is 412.
No, 069.
No, 069. Okay.
So author of this 69 is present here. Shivani Swadi.
Yes, sir. I'm present here.
So you are the presenter, so you can share your screen and start your presentation.
Okay, sir. Sir, is my screen visible?
Yes.
Yes.
Yes, sir. Greetings to all. I am Shivani Swadi from KLE Technological University, Hubli. I appreciate your time as I present a paper on novel approach in the field of artificial intelligence that holds significant potential for various industries such as robotics, surveillance, and autonomous vehicle. The title of the paper is Pixel Level Segmentation for Multiple Object Tracking using Masked RCN and FPN. The paper ID is 069. The agenda here is firstly, we will discuss about the introduction to pixel level segmentation and why we have chosen this method. In implementation detail, we will be focusing on block diagram, mathematical modeling, and network architecture. The next about validation on different data set and optimization technique. And lastly, I'll be showing you the results and will also compare with the related work. To begin with the introduction to pixel level segmentation, firstly we will discuss about the challenges that we are facing by the well established approaches. First one is challenges with bounding box level tracking. Segmentation and monitoring several objects is a difficult but necessary operation in the field of artificial intelligence. This has wide range of use including robotics, autonomous cars, and medical services and surveillance. When it comes to well-established approaches, bounding box level tracking is the most commonly used. The traditional approach have shown to be quite successful in applications such as object detection and image segmentation. Nonetheless, effectively monitoring many objects between frames is a difficult challenge. L- Challenges in dataset often lack information such as unique identifiers, which are crucial for training and evaluating computer vision system. Incomplete or missing information in the dataset can hinder the development and assessment of effective tracking models. Hence, working at the pixel level is the most promising strategy instead. With regards to occluded and overlapping object, this shift to pixel level analysis is intended to improve object tracking with precision and accuracy. It makes it possible to depict the scene with greater accuracy and details, especially when working with items that are obscured. Segmentation masks give a more precise representation of ground truth than bounding boxes, which can only provide a approximate match for objects. Here is the block diagram that will be I'll be following, and this block diagram gives advantage of segmentation based tracking over the box based tracking. Segmentation per pixel enables excellent identification even in the cluttered environment with overlapping component. To accomplish per pixel segmentation, instant segmentation utilizing a compact picture representation is used, with each pixel receiving a unique label to distinguish between instance of an object in an image. Instant embeddings are learned from processing point cloud by treating the pixel in the 2D image as an unordered 2D point cloud. Instant embeddings are items that represent themselves in a higher dimension space and group similar objects together. So these 2D unordered 2D point clouds again further divided into foreground unordered 2D point clouds and background unordered 2D point clouds. The foreground in an image, the object of our concern is considered to be an foreground image, and its pixels are considered in uh, foreground unordered 2D point clouds, while all other points which are not related to the concerned image are categorized into the background unordered 2D point clouds. These are concatenated with the different data modalities of a point-wise features, and here we get a unified and context-aware embedded instant embedding. This again instant embedding undergoes instant association to form the results. In the next three slides, we will be discussing about mathematical modeling and tracking by point network architecture. Let us consider a input instance in which we will take a small segment and enlarge it by a factor of zero point 0.2 in all four direction, and let us denote it as CB. The foreground segment is considered to be as a 2D point cloud as F, and the remaining area in the CB is considered as environmental point cloud, and it is denoted by E. Each point in the CB has six dimensional data spaces, that is UV, RGB, and C, where UV represents the image plane coordinates, RGB represents the pixel color, and C represents the a class to which a image or a pixel belongs to. Four data modalities are considered for feature learning, that are offset, color, category, and position. Offset data represents vector from the instance center to each point, providing information about the relative location inside the segment, and it is evaluated with this formula. The color RGB channels are used for color data to learn discriminative appearance features from foreground points and color distribution from environmental points. The color data are crucial for accurate instance association. Category is the semantic class label, including the background classes are encoded into the fixed length one hot vector to incorporate environmental context. And strong context features are learned by point track by jointly learning from the category data and offset data. The position of the circumscribed rectangle CB is encoded into the position embedding to consider its position in the image plane. In the network architecture, here initially the input image is segment in undergoes instant segmentation by masked RCN and FPN mask, and here from this we will get the different segments, that is background mask and foreground mask, and from these we will be doing feature extraction and learning embeddings are formed. The foreground embedding in which we will be doing the uniformly and random sampling we will do with the factor of 1000, and we will get two types of data modalities, that is offset and color. And from that data modalities passing through multi-layer perceptron and point waving, we will get the foreground embedding. Similarly, with the environmental embedding, here we will sample it with the factor of 500, and then we will get three different data modalities, and that are offset, color, and category. After concatenation of these three data modalities, we will be getting the environmental embeddings. For instant association, similarity between instances are computed based on the learning embeddings. The similarity matrix consider Euclidean distance and mask intersection over union (IOU). The instant association is performed using a similarity threshold and Hungarian algorithm. Tracking and updating active tracks are updated based on the computed similarities. The tracks that do not get updated for a specific number of frames are ended automatically. Unassigned segments after instant association starts a new track. The procedure combines various features and context information to perform robust and accurate instant association for object tracking in computer vision. Validation on different data set. Initially, we have validated our model on three different data sets, that is Kitty data set, Apollo mods data set, and IDD data set. In all three, we have got a good results. The first one, Kitty data set, it consists of two subsets, one for tracking and segmentation, in which it has 21 videos, 10 frames per second, and each of 40 seconds. And the other one is for object detection, in which it has 7,481 annotated photos with item position and class name. Here we have achieved the F measure score of 68.8, and it is one of the best performing algorithm on Kitty Mods data set. In Apollo Mods data set, it includes 1,50,000 annotated frames with diverse traffic setting, weather, and objects like vehicle. It provides instant segmentation, mask, and tracking labels with the object detection position and size information over time. And here we have obtained a F measure score of 75.9 on Apollo Mods dataset. The Yes, sir.
Please continue. Sorry.
Yeah. The IDD dataset, it is developed by Triple IT Hyderabad, in which it features over 10 hours of driving footage from various Indian cities. It includes pixel level annotation for objects like cars and pedestrians and bicycles. On this, we have achieved a F measure score of 62.3 on IDD dataset. The optimization technique, one of the key feature technique in learning rate scheduling. We start with the initial learning rate of 0.001. The learning rate is dynamically adjusted, decreasing by a factor of zero point 0.1 every 10 epoch. This dynamic adjustment help prevent slow convergence and ensures optimal performance over time. The weight decay is employed to prevent overfitting and enhance generalization. We use weight decay value of um, 1 to the power minus 4 or 5 to the power of minus 4 as a penalty term in the loss function. Batch normalization is another powerful tool. During training, it normalizes the activation of each layer for every batch. Uh, for object tracking, we introduced particle filtering. We utilized 100 particles with resampling threshold of zero point 0.5. This approach ensures robust and accurate tracking by estimating the state of the object over time. To further enhance the tracking accuracy, we have integrated the Kalman filter, predicting each object's location and velocity based on the historical data, ensures continuous tracking, even if object momentarily disappears from the frame. As result and discussion, our technique have revolves around the masked RCN and FPN model, a robust solution for object segmentation. However, the real magic happens with the tracking by point network, which treats the object segments as pointer, allowing for an unparalleled combination of tracking and segmentation. We have put our techniques to test on the benchmark data sets like Kitty mods, Apollo mods, and IDD data set, in which we have renowned video object segmentation and tracking. The result speaks for themselves with the F measure score of reaching 68.8 on Kitty Mods dataset, 75.9 on Apollo Mods dataset, while 62.3 on IDD dataset. Our method involves two primary stages, masked RCNN model, segment objects in input frames, providing a foundation for accurate tracking. In the second stage, the objects are treated as point, and tracking algorithm, including the Hungarian algorithm, ensures accurate and efficient tracking. The performance matrix, our approach is evaluated using metrics such as intersection over union IOU and multi-object tracking accuracy MOTA. In experiment, we have achieved average MOTA of 60.2% and average segmentation IOU of 70.9%, setting to accuracy and efficiency of our method. If we talk about the real-time processing efficiency, practicality matters. Our approach boosts real-time processing efficiency, achieving up to 27 frames per second on a single CPU. This makes it not only powerful in performance, but also applicable in the real-world scenarios. These are few results. This is the result of masked RCN and FPN module, in which we will get the initial segmentation. And here, as you can see, we have got we can take
Shivani,
Yes, sir.
sorry for intervening. Please conclude your paper in 2 minutes.
Yes, sir. Yeah. Here we will get the background and foreground images, and these are the results captured on the Indian roads. This first one is for vehicle and the second one is for pedestrian. Here we can here are a few comparison, and in com we the our method again we compared our method against state of art techniques, specifically focusing on vehicle and pedestrian, and we have the key matrix we have used is MOT, multiple object tracking accuracy, multiple object tracking precision, multiple object detection and segmentation accuracy, ID switch, and simple multiple object tracking accuracy. As you can see, we have got a good improved result compared to the other benchmark methods. To conclude, our method excels in comparison to the state of art 2D methods for both vehicle and pedestrian, utilizing masked RCN and FPN model and point track network for object tracking. F1 score of 68.8 on Kitty mods, 75.9 on Apollo mods, and 62.3 on IDD datasets demonstrate excellence. And we have achieved average MOTA of 60.2 and average segmentation IOU of 70.9%. Also in real-time processing speed up to 27 frames per second on single CPU. Holds significant potential for real-world application in robotic surveillance, autonomous vehicle, and even in medical services. Superior accuracy and computation efficiency makes it a promising solution. Thank you. I'm open for questions in discussion.
Okay. Hello, Shivani.
Yes, sir.
So, what is the role of mainly of using this mask RCN and FPN in your pixel level segmentation for multi-object tracking?
Sir, here we will be needing initially we will need the segmentation, sir. So initial segmentation is done using masked RCN and FPN, and those segmented points are again considered as points, and then we are doing the further process.
Okay, thank you.
Okay, one
Yes,
participant from the audience, I think he has a question. So Tunji, you may ask question. You raise hand for asking question. Tunji John, Karina, have you raised the hand to ask the question? No, he's not replying.
No, I think he just raised hand and forgot.
Yes.
Okay, so we invite next participant, paper ID 122, Onto Opinion Miner, an opinion mining algorithm for drug review. So, is there anyone?
Hello, sir. Am I audible?
Yes.
Yes. Please raise your hand so that I can make you the presenter.
Is it visible?
122. Yes, yes, it is
Paper
visible.
ID 122.
Yes. So now you are presenter.
Yes, sir. I got the presentation rights. Give me a
Yes.
moment. I shall share my screen.
Sure.
Just to confirm, is my slideshow visible?
Yes, it's visible.
Sure. A very good afternoon to one and all present here. This is Rashi Srivastava. My paper ID is 122 and the title of my paper is Onto Opinion Miner, an opinion mining algorithm for drug reviews. So, going about the paper outline, we shall be covering the introduction. Then we'd be taking up the related works, followed by problem definition, proposed methodology, results and discussion, and conclusion and future scopes. And finally, we'd concluded with references. Uh, Opinion mining has been one of the most studied fields along the lines of data mining and natural language processing in recent years, as we all know. However, the methods to extract the important parts of healthcare sector are still lacking. There are patients who constantly look for reviews of a specific drug from other users. So, in order to estimate the drug satisfaction rate, the proposed approach includes a novel threefold feature selection and classification architecture, which we'll be talking about later. The prime objective of this study is to come up with an efficient architecture which will inspect the patient's comments on drug satisfaction quotient and classify it into negative and positive review, which can further used by the patients. So this approach has been presented consolidating the random forest classifier and LSTM to obtain a final classification. Feature extraction is also done on a single data set in a threefold fashion for better results. So talking about the problem we are working on, so the existing work done by other researchers, it can be seen that opinion mining has been predominantly used for general fields like products, materials, etc. And healthcare domain has been overlooked. While the application of opinion mining can significantly help in this field, so we have tried to propose a solution to it. Henceforth, a new strategy is proposed taking into regard the drug satisfaction level among patients to trace down the effectiveness or adverse reactions through a drug using social repository. So, going about the proposed methodology, so our objective, as I have already spoken about it, so the data source which we have used is UCI ML drug reviews. We'll talk about it in detail later. A threefold feature extraction technique has been used, as I mentioned before, which includes TF, IDF, and information sent for significance mapping. Then opinion alignment is done under sunflower optimization. And finally, we concluded with feature weights based on semantosim for enhanced opinion mining. Here we have used a hybrid classifier, which is a combination of LSTM and random forest, and optimal weight selection through sunflower optimization is also done. Then we have also taken into consideration ontology alignment using less similarity and semantosim on drug efficacy and side effects ontologies. Now, we have also incorporated natural language processing for pre-processing our data set, which includes tokenization, lemmatization, and stop word removal. And named entity recognition for identifying crucial elements has also been done. So this is how the procedure looks like, and going quickly over it. So what is done is by supplying the raw data to the pre-processing stage, it is first made consistent and turned into a comprehensible format. Textual data is tokenized, lemmatized, and stop words are eliminated after that. Then NER is incorporated to pick out the primary elements from the text corpus. Once the data set is cleaned according to model demands, the TF-IDF score is then calculated for each of these tokenized terms, taking into consideration information sent value. This vectorized data is subsequently directed for ontology alignment using less similarity measure and semantosim score calculation. SFO is implemented. SFO, which is sunflower optimization, is implemented to optimize the algorithm and refine the model accuracy. Thereafter, feature weighing is carried out through contingent on semantosim value and information sent. Finally, classification is performed utilizing the hybrid classifier constructed with a fusion of LSTM, which is long short term memory, and random forest. And we have used two ontologies, as you can see here, drug efficacy ontology and drug side effect ontology. So talking about the implementation of the same, the language used is Python, and we have used Spider under Anaconda environment to implement the entire procedure. The data set, as I said before, is the drug review data set from UCI ML drug review repository, which contains reviews for about 3436 unique drugs divided into 23 different classes. So since we needed only few of these features, so significance has been given to 5 features of the data set, that is medical condition, user review, rating, useful count, and side effects. RAM and ROM of the system uses 8 GB RAM with Linux operating system. So the algorithm as it follows is, the process commences with accusation of the drug review data set. Then, as I told, pre-processing, tokenization, lemmatization, and stop word removal. So tokenization is nothing but dividing the text into tokens, which is different words, and then unifying inflected forms of terms. There can be words that are same but are used in different forms. So we try to lemmatize it there, and then we remove the stop words, which is the common helping verbs are removed, and then name entity recognition is done, which is identifying and extracting essential elements from our entire text corpus. Then a novel threefold feature extraction method is employed to create feature vectors, each playing a pivotal role in sentiment analysis. So TF-IDF is done where we compute the term frequency inverse document frequency scores for each term to gauge its significance in the entire text. And then we extract the reliable cues from these texts in text corpus, refining the feature data. And then we do ontology alignment, which is feature vector. The feature vectors that was formed before are aligned with drug efficacy ontology and drug side effect ontology, streamlining connection between terms and ontology concepts, which is giving meaning to each of the words that are there in our text. Less similarity is used to minimize the ambiguity by determining the shortest distance between words so that we can go to the actual meanings of it and finally use it for the purpose that we need. And then we enhance the semantic matching of tokenized words based on probability of mutual information score, which is also known as PMI score. Then we use optimization with sunflower algorithm. This is an iterative optimization algorithm which fine-tunes semantic matching parameters, boosting model accuracy and reducing time complexity. Feature weighing is done wherein the term weights are assigned within the feature set, incorporating semantosim values and information sent. So based on semantosim score and information sent score, each of the terms are given weights. These weights provide accurate term contribution to the final classification. Then sentiment classification is done using LSTM and random forest. So as we can see here, these are the results. We have compared our overall algorithm with the 3 base papers and modification to our algorithm itself. So here BP1 shows BP1 is a 2-pass opinion mining. So as you can see, the scores here for precision, recall, accuracy, F measure and FNR. The best that we can see here is of OOM, which is nothing but proposed onto opinion miner. So for base paper 1, it has been found that despite the fact that it has 2 pass classifier, it aids model achievement of a high accuracy rate over the long term. It renders the model much more unstable. Also, a combination of SVM with neural networks has been used there, which does not provide much remarkable results. As we can see in base paper 2, which is subject lexicon construction. So here in for drug review, opinion mining doesn't help much in achieving higher accuracy. They have incorporated CentiWordNet, which alone cannot result in feature selection, and it rather leads to imbalance, which eventually affects the model performance. And in baseline paper 3, another approach has been taken up of probabilistic aspect mining. Though only relevant aspects are taken into consideration for sentiments, but due to proper data segmentation issue, the overall efficiency of the model drops down. Then for further comparison, we even tried to eliminate ontologies from our proposed algorithm. So doing that, removing ontologies from the algorithm, it drastically affects the model accuracy, as the incorporation of ontologies enhances the background processing of a model. It refines the process of feature extraction and filters out the irrelevant entities, which eventually qualifies the input data as being sounder and more misleading. Then we also tried eliminating feature weighing. So elimination of feature weighing strategy results in redundant data being left along with useful data, which affects the data consistency and further makes the data statistically unstable. So all baseline models only provide predictions for a smaller number of data points, but a sizable amount of data has been used to conduct experiments on the proposed framework. Additionally, the new approach of combining each of the previously mentioned strategies together helps to improve the performance and accuracy of the model. It's actually like each algorithm complements the other, which makes the proposed onto opinion miner capable of outperforming all the baseline methods currently in use. We can also see the same result based on the precision percent versus number of recommendations, and the green line here shows the proposed onto opinion miner, which we can see gives the highest percentage for precision. So coming to the conclusion, the proposed onto opinion miner puts before a classification algorithm to separate negative and positive reviews on a particular drug, incorporating various novel strategies and methodologies. A hybrid of random forest built on top of LSTM has been used as a prime classifier to get the final review prediction. In order to create a calculated and appropriate pipeline for the efficient classification of all the textual data available in the corpus, this methodology combines multiple algorithms. That was the whole purpose of it. And the threefold feature extraction, as I mentioned before, is the highlight of the whole algorithm, as it helps to define and stabilize the data in a way such that overall performance of the model is elevated. Usage of sunflower optimization as an optimization algorithm makes the overall model robust, and remove all the inconsistent data to avoid final stage chokes and skepticism. So the proposed methodology has an average precision of 95.83% and an average recall value of 90.71%. Additionally, 92.72% of 8 emotions considered were currently predicted on average. The proposed method secures an FNR rate of 0.92 and an average F measure value of 93.75%. The future work on the system could likely concentrate on boosting its overall relevance. To get even better results for assessment matrices, it is also possible to apply other strategies for estimating semantic similarity or co-occurrence, or to get better results, attempt to combine different neural networks with classifiers from machine learning can be fruitful. So these are the things which can be tried upon it. So here are the references which I have used, and the first 3 are the ones which were considered as the baseline papers. Thank you so much.
So once move to your references.
Sir, can you please repeat?
Move to your references slide.
Yes, sir.
So you have used, I think last 2019 onwards, you haven't taken any paper. So is it relevant or some more work is there after 2019?
So I even took reference from a paper in 2022, as you can see here, although the base papers that were considered were from 2019. But I have taken reference from the papers which came out in 2022 as well.
Okay.
Yes.
Okay. Any more questions from?
Any question from the
Anyone?
audience?
Okay. So thank you. Next paper ID is 153. Using machine learning techniques and algorithms for predicting the time length of publishing a law in the domain of e-parliament.
Actually,
So
Dr.
153.
Dajesh, the author of 153, paper ID 153, will be presenting her paper later in other session.
Okay.
So we
Okay,
need
okay.
to move to the 183.
Okay. So next paper ID is 183.
Is author of
Metagenomic gene prediction using bidirectional LSTM.
Is author of 183 present here in audience? Actually, author has submitted a pre-recorded video. But if they are present here, then we can call him to present. Else I will play the video. Okay, let me play the video.
Good afternoon, everyone. I'm Shamaki, research scholar in Mitzvah Dubai campus. I'm here to present my topic on metagenomic gene prediction using bidirectional LSTM. My paper ID is 183. The outline of the presentation is this: introduction, contribution, literature review, and proposed methodology, experiments, results, and then conclusion. Metagenomics is the field of genomics which involves the study of genetic material collected from environmental samples. Then gene prediction is the process of identifying the regions in DNA sequence that can encode a gene or a functional protein. Traditionally, the wet lab experiments are used to identify the genes present in a DNA sequence. These wet lab experiments are quite expensive and time-consuming. Then computational methods came into picture. There are two categories of computational methods: similarity-based method and content-based method. Similarity-based methods find out the similarity of the new DNA sequence with that in the existing database. So it is computationally expensive. Another one is content-based. In content-based, the features are extracted from the DNA sequence, and those features are used to identify which organism it is, or identify the position of genes in the DNA sequence. Compared to other gene prediction methods, metagenome gene prediction is challenging due to the fragmented and diverse nature of data. So ML algorithms has shown promising results even though the sequences are fragmented. All the ML algorithms try to learn the characteristics of the sequences with the ORFs. ORFs are the subsequence of DNA or RNA that has the potential to be translated into a functional protein. So all of the ML gene predictors try to classify the given ORF is coding or non-coding. A coding ORF is the ORF that has the ability to be translated into a functional protein. Non-coding ORFs, they are also genes, but they do not translate it to the protein. So when we consider the ML algorithms, RNNs, recurrent neural networks are very effective in handling sequence data. There are different varieties of RNN, which are long short-term memory LSTM, gated recurrent units, GRU, bidirectional LSTM, bidirectional GRU, and the new one, transformers. The LSTMs are widely recommended for tasks involving sequences because they are designed to avoid the problem of RNNs, the problems such as vanishing gradient and exploding gradient. So in this study, we use bidirectional LSTM, which are extension of LSTM but more powerful than LSTM. The contribution of this study are a gene predictor model is proposed using BiLSTM to classify the input OR of sequences into coding or non-coding. Various hyperparameters of the BiLSTM model are tuned using hyperparameter tuning. The results of the proposed BiLSTM model are compared against existing model and other models like LSTM and CNN. Literature review. So I've taken 5-6 papers here as literature review. The first, all of them use ML or DL methods. The first study used an ML approach, two-stage linear discriminants for feature extraction, then neural networks for the final classification. Second study used a minimum redundancy, maximum relevance algorithm for feature extraction, then SVM for classification. The third study extracted features manually from the DNA sequence, and a random forest classifier is used to classify ORF into coding and non-coding. In this side, CNN MGP used CNN model. There is no feature extraction in that, only the CNN model directly classify given ORF is coding or non-coding. They divided the entire dataset into 10 different classes based on the GC count. Then VirSearcher is another study. Their aim was to identify the viral sequences among the metagenomic datasets. The viral sequences are bacteriophages that infect the bacteria in the dataset. They used a CNN model. Before that, they applied a word embedding layer to convert that DNA sequence into numerical data. The last one is the study called Balrog. They used a temporal CNN, and the advantage of temporal CNN, which simultaneously extract the temporal feature and the spatial feature present in the DNA sequence. So all of the study used ML or DL method. Our proposed methodology is like this. We have a set of ORF sequence in our dataset. We apply pre-processing on that, then divide that into train, validation, and test set. The train and validation test is used for the hyperparameter tuning. And after this hyperparameter tuning, we get the parameter values, optimum parameter values, and the best model. And this best model is used to evaluate the test data is used to evaluate the best model performance, and the values, the metrics are recorded. The first one is the dataset we used. We have used a dataset of 7 million ORF sequence from 131 prokaryotic genomes. The labels of the ORF sequences are binary, which indicates whether the ORF sequences are coding or non-coding. Due to limited computational power, we have extracted or we have sampled 1 lakh ORF sequences from this 7 million ORF sequence. Out of this 1 lakh sequence, 49,975 sequences are coding, 50,025 sequences are non-coding. After that, this 1 lakh ORF sequences are converted into numerical data using pre-processing. So in the pre-processing step, we used one-hot encoding to convert them into numerical data. And after, we divide them to train, validate, and test data. The methodology. The LSTM networks are used. LSTM networks are designed to overcome the vanishing gradient problem of RNN when working with long sequences. The vanishing gradient problem occurs during the training of RNN. The gradients involved in the back propagation becomes extremely small as they pass through multiple time steps and the network layer. This makes the learning of long-term sequences challenging. LSTM has gates such as forget input and output. These gates play a crucial role in regulating information flow within LSTM network. So from this figure, LSTM architecture, we can see LSTM architecture is complicated because of this lots of activation functions, the gates, etc. So these gates regulate the flow of information in the LSTM network. The forget gate determines what data should be erased. The input gate updates the memory cells, and the output gate decides the next hidden state in the model. So all these gates helps to store relevant information from the long-term dependency and to erase irrelevant information. And we used bidirectional LSTM, which the heart of bidirectional LSTM is again LSTM, but in both directions. So we get more features from the DNA sequence, input sequence, because the two layers of LSTMs are scanning our input sequence in both directions. So 2 LSTM operates on the same sequence in both directions, and both LSTM's output is concatenated to get the final output. The experiments we have done hyperparameter tuning. The parameters used here or which taken for tuning are hidden layers, and the grid of parameters are 1, 2, 3. The number of units in the hidden layer 4, 8, and 16 we tried. Then optimizer, Adam, and attack rate. Dropout rate 0.3, 0.4. And with all this grid value, all these parameters, the grid search is ran for 150 epoch with an early stopping criteria with the patient's value 10. The model with best validation accuracy is saved and the parameters are recorded. The comparison is done with the CNN and LSTM model. The CNN parameters are like this and LSTM parameters like this. The results of hyperparameter tuning is shown in these 3 tables. The first table with 1 hidden layer, this table with 2 hidden layer, and this table with 3 hidden layer. From the figure or from the tables, we can see that the LSTM with 2 hidden layers with number of units 8 and 16, Adam optimizer 0.3 dropout rate gave the better validation accuracy of 0.954. This setting is used, or this LSTM model is used for the final comparison also. So from the final comparison, we can see that the LSTM model outperforms LSTM and CNN models with this metrics, a good accuracy of 0.9537. And also we compared the best LSTM model with an existing CNN MGP work. There also our LSTM model outperformed the CNN MGP model in all the values. So the improved results of LSTM shows that it can capture more context and long-term dependencies in the input data in both forward and backward directions than LSTM and CNN. Finally, the conclusion. The study uses a LSTM model to classify ORF sequences into protein coding ORF sequences or non-coding sequence. Pre-processing of the ORF is done with one-hot encoding, and this one-hot encoder vector is passed to the LSTM layers. The final dense layer in the LSTM layer gives the probability of ORF encodes a gene. Hyperparameter tuning is also done. And the proposed LSTM model produces promising result when compared to CNN and LSTM model. The disadvantage or the limitation of the work was the hyperparameter tuning was taking a lot of time to finish the grid search. Then as a future work, we plan to use transformers for the classification task. These are the references used, and that's all. Thank you.
Is author
Okay,
of
sir.
paper ID 183 present here in audience? Shyama? No. So can we move to the next paper 184? Dr. Dadesh?
Yes, sir.
Author has submitted pre-recorded video, so I need to play
Okay.
it. Just
Yes,
give me
sir.
1 minute.
My name is Dr. Akinshola Jet.
Just a minute. Oh, it's a 17-minute video.
My name is Dr. Akinshola Jet. I'm presenting a paper on machine learning enabled image classification using k-nearest neighbor and learning vector quantization on the 5th International Conference on Soft Computing and its Engineering Application. My co-authors are Onipede F.O. from the Department of Computer Science, First Technical University, Ibadan, Nigeria. Professor Iye Olajubu, Department of Computer Science and Engineering, Obafemi Awolowo University, Ile-Ife. I'm Professor Aderounmu G.A. from the Department of Computer Science and Engineering, Obafemi Awolowo University, Ile-Ife, Nigeria. The table of content is as presented. Introduction, related works, materials and method, results and discussion, conclusion, and reference. There has been a lot of issues around image classification, and this is usually in relation to bridging the gap between human vision and computer vision in order to identify images by machine in the same ways humans do. But there has been a lot of challenges around how to classify these images. A majority of the problem encountered in image classification is representation of image vectors as well as feature extraction. Therefore, machine learning techniques is handy in solving this problem. There are various types of learning depending on the particular use case and the areas of application, which can lead to several approaches. Machine learning uses different classification algorithms for performance metrics evaluation, and these learning can belong to classes, major classes such as Bayes, trees, function classifier, and lazy classifier. The machine learning algorithms were implemented in this study to build the models to overcome major image classification issues. Algorithms such as KNN and LVQ are implemented using scikit-learn and Python packages on the iris datasets. 70-30 split ratio was used for training and testing the models, and the performance evaluation was compared using machine learning performance metrics such as accuracy, F1 score, recall, and precision. There are major contributions of this study to the body of knowledge. Building of machine learning model using iris data set on different splitting ratio, improved performance result better than the existing models and solutions, comparative analysis to choose the best image classification model, applications of KNN and LVQ mathematical models for image classification. Several works have been done by various researchers, but there are issues around the selection of the effective distance, which has been the challenge, where some of these solutions are not really giving optimal results. In relation to KNN, the user-defined parameter key determines the number of neighbors, and the forecast is usually based on the average value or majority class of the k closest neighbor. As regards learning vector quantization, this is inspired by logical representation of brain systems. It's a type of artificial neural networks, and the network is trained using a competitive learning strategy, which is closely related to self-organizing map. And this is used in producing the prototype that is based on supervised learning classification system, and it addresses the problem of multi-class classification. There are two major layers usually used in the learning vector quantization. These are input layer and the output layer. Existing solutions failed to determine effective distance and equilibrium distance in a multi-dimensional space for optimal algorithm performance of the KNN model. And that is what this study has profiled the solution into determining this distance. There are major variations of KNN. We have the weighted KNN, which is usually defined by the distances between the sample and its neighbors. We also have the variant known as KNN with dimensionality reduction. The whole idea of this is to alleviate the problem of cost of dimensionality by initially carrying out dimensionality reduction, such as principal component analysis or locally linear embedding. The third variant of the KNN is the KNN with feature extraction. This performs better when there are fewer duplicated or irrelevant features. We also have the KNN with hybrid distance measure. This enhances the performance of KNN by making use of hybrid distance measure, which incorporates various distance metrics. We have the KNN for regression. This is used when the target variable is continuous rather than. There are 6 major learning vector quantization variations. The first one is LVQ1, which is the winner takes all. This is a greedy approach. This is like a greedy approach because the solution is only after getting the best solution, irregardless of the cost. We then have the LVQ2. In this case, the input vector has a particular weight, which enables more precise classifications to be possible. We also have the LVQ3. This is used in relation to online learning and where real-time modification of the weight vectors is desirable. We have adaptive LVQ. This modifies the learning rate in response to classifier performance. We then have the self-organized map, which is an unsupervised learning technique, frequently thought of as a subset of LVQ for data visualization and dimensionality reduction. The last one of the learning vector quantization variant is the adaptive resonance theory. This is a form of neural network developed for pattern identification and classification, and this was largely influenced by the learning vector. There are various significances of learning vector quantization. One is the automatic classification. This is used to carry out classification of input vector automatically, and it enables quick identification of characteristics of image. Another importance of the LVQ is the creation of prototype. It makes it easier for experts to translate to respective application domain through the creation of prototype. Another significance of LVQ is the multidimensional data processing. This is very handy when the dimension space is so large, and then LVQ can handle data processing where the data is noisy and at the same time there are a lot of duplication. Materials and methods. The data set consists of 4 traits, which are sepal length, sepal width, petal length, and petal width, that distinguishes each of the 150 samples of the iris plants. There are 3 species used in this study. We have Iris setosa, Iris virginica, Iris versicolor. To enable us in building an effective model, series of data processing activities were carried out, which includes data cleaning, data normalization, data division, data transformation, using tools such as scikit-learn and some other Python packages and modules in order to build an effective model. Lazy classifier, usually referred to as k-nearest neighbor, and learning vector quantization were the algorithms used. These algorithms were evaluated using data mining approaches such as training data, validation data, and test data. 4 performance metrics were used to determine the effectiveness of the model. Metrics such as accuracy, recall, F1 score, and precision. There is a need to validate the reliability of any developed model. In this, we were able to determine the ratio of the false positive to false negative, and this will give us a true picture of what the model is actually all about. Architectural model for image classification was developed, and then there are 6 phases in the architectural model development for image classification. We have phase 1, which is data acquisition and data preprocessing. We have phase 2, which deals with machine learning classifications and prediction, where the data set was imported, the best splitting ratio was determined, then also the identification of training and testing data sets in building the model. Phase 3 deals with how the trained model was fixed in order to predict the testing data set and generation of performance evaluation metrics in order to validate the reliability of the model. Stage 4 deals with the optimization of the metric result using Adam parameter optimizer. Phase 5 deals with deploying of the chosen model, and lastly, phase 6 deals with building image classification. There are 5 processes, major 5 processes involved in the image classification, which is as presented in the process flow. We have the first process, which is the one that deals with the importation, handling of missing value, data normalization, standardization using standard scalar. The second phase denotes the splitting ratio of 80 to 20, 70 to 30, 75 to 25, and 60 to 40 respectively. The third process of the process flow deals with the building of KNN and LVQ models. The fourth process is choosing the best algorithm out of the 2 by using their performance evaluation metric result. Fifth process is the implementation of the best algorithm and determining the decision if the result from each matrix is optimal. If it is optimal, the model will proceed to the evaluation and testing mode. And if it is not at the optimal value, the model is retrained for better performance and the final output that is based on the best image classification and prediction result was then chosen. The results shows that KNN has an accuracy of 96.67%, precision of 1.0, recall of 0.89, and F1 score of 0.94. While the LVQ has the accuracy of 80%, precision of 1.0, recall of 0.8, and F1 score of 0.8. The result clearly shows that there is a better performance from the model as a result of the data preprocessing activity and the type of splitting ratio that was chosen in building the model. It was shown clearly from figure 3 that the accuracy of KNN was better than that of LVQ, as well as consideration regarding precision, recall, and F1 score. In order to validate the reliability of this model, the developed model, which is our proposed model, was compared with some other models in this domain. According to author in 23, comparison of iris data set using classification technique shows an accuracy of 93%. And another study by the author in 24, that deals with the classification of flower images by using different classifier in orange, gives an accuracy of 82%. And our model, where we carry out some data preprocessing techniques and determination of the best normalization approach, gives 96.67%. And this result shows clearly that our result is better than other one in comparison with the building of the model using. The conclusion from this study shows that both algorithms like KNN and LVQ, while performing differently, are useful for different classification tasks. It also shows that KNN model can generate new data more efficiently based on the metrics result. It is also important to carefully choose an algorithm for certain classification tasks because every algorithm has its own strengths and its own shortcomings. And this clearly shows that the no free-lunch theorem in machine learning is upheld, in which case there is no single algorithm that can outperform every other algorithms in every respect. The study therefore recommends for further studies implementation of deep learning using larger data set. Thank you so much for listening.
Yes, Dr. Daljesh,
Okay, sir.
you may conclude the session.
So I am very thankful to
Hello?
Dr. Kanubhai Patel, sir.
Hello.
Yes,
Yes.
Sir, I have a question regarding to the previous session, previous paper.
You may ask, but the author is not here present.
He has not identified the splitting method. Which splitting method, K-fold or stratified or anything. Also, he has not done EDA analysis.
Right.
Okay,
Yes.
you can write down a mail to sir
Okay,
on
okay.
conference mail ID.
Which
And I will
paper ID
forward
was
that.
there?
You send me email and I will forward to the author.
Sir, can you tell me the paper ID?
Paper ID was like 184.
184. Okay, sir. Thank you.
Right. Thank you. Yes, Tunji, you have question?
Hello.
No, sir. Yes.
Hello.
Yes.
Good morning. My question is on this last for the last presenter.
Your voice is recorded.
Hello.
Yes.
My question is, what is the best percentage for training and testing of the algorithm of the analysis in machine learning?
Okay, Tunji, actually author is not present here. So you need to send me email with your query and question. I will forward to the authors.
Thank you.
Thank you. Now we are behind the schedule. Just a minute. So Dr. Dajes, thank you very much for sharing the session and sparing your valuable time for us. Thank you very
Thank you,
much.
sir. Thank you, sir. Thank you so much.
Okay.
May I leave, sir?
Yes, you may leave.
Okay.
Dr. Parmar, shall we start your invited talk?
Yes, sure.
Yes. So you are presenter, so you can share your screen.
Can you see my screen?
Yes, it is visible.
And can you hear me well?
Yes.
Perfect.
Perfect.
Then, yes. Then thank you, Dr. Patel, for inviting me for this talk, and thank you all for your time. I'm Ashish Jalote Parmar. I'm Associate Professor at the Department of Design at the Norwegian University of Science and Technology. As you can see from the diagram, I sit in mid-Norway. So currently we are facing the night time. Therefore, we have only a few hours of daylight, and it's very cold. The temperatures are now minus 20 to minus 50. So that's where we are. Yes. So very.
Okay.
Yes. So a very warm. Patelji, I think I'm overhearing something.
Just a minute. Yes.
You will be very happy, no? And I'll be.
Sorry for interrupting.
No. Can I continue?
Yes.
Yes. Okay.
Yes.
So thank you all, and I'm going to transport you to a very different world than what you've been hearing in the talks today. It is a role of design research in health innovation. So I'm an industrial design engineer, but I worked in health innovation for the last 15, 20 years. I lead a global health research group here. And also I'm a leader of a lifelong learning program on service and strategy in our department. My India Connect is that I have been a former faculty in IIT and IM, and also I set up SES in Ahmedabad University. So I've had a multidisciplinary background, but my core strength is health and innovation. And here in NTNU, we work very, very closely with the hospitals. So Norway has a very exemplary example, and my doctorate has been from here, where I worked very closely with the doctors, with the surgeons and cancer specialists to create new innovative solutions. And all over Norway, all the hospitals and universities are very closely bridged together. So that's a very exemplary situation. I'll be sharing approach of design research, how we do conduct design research, and what value does it add to health innovation, and some open issues. And I'll be taking two cases, one of the case that I have pursued myself and the other I have supervised. So what is design research? If you see, it is user-centered research which considers the context around the users and the larger system which the user is connected to. So that's very, very critical. So it's actually a user research you can also understand as problem-solving process that can visualize, shape tools, societies, products, businesses, and environments by driving user-centered and sensitive innovations. And the user connect and the context connect is the strongest point that we can offer in terms of value added to any kind of innovation. Now, health innovation, as we all know, is highly complex domain and a very broad domain. And the complexity is because it has so many parameters associated to decision making from experts, from patients. It's organic, it's volatile, it's dynamic, and when in terms of approvals and FDA approvals, it goes to a very long curve of development. So how do you start that curve at a very start level, at the university level, at the research level? We are working on innovation of products which can directly impact the society. So how does design research add value onto that? Some process tenets are that it's human-centered tech development. So technology can do a lot, AI can do a lot today, but that's not deliberated. What is deliberated and what is really important is that humans are central. And who are the humans? It could be the end patients, it could be the families, it could be the doctors, it could be the experts who really need that data for decision making and nearly need the technology for decision making. So you can have AR, you can do a lot of VR, you can do a lot of AI stuff, but finally it has to end up with better decision making, optimizing time, and reducing a lot of learning curve if you look at that way. So supposing if that surgeon is learning a new technique in minimally invasive, can technology reduce the learning curve? So there are a lot of issues that can come in, but technology has to serve the humans, and that's the prime reason. Second is that it is innovative problem framing. So design research offers innovative problem framing in terms that it incorporates innovative and unmet social needs. For example, I work in the area of women health and many other areas of obesity and so on and so forth. There are many unmet needs. Innovation has not reached there. I wonder why. The case that I'll be taking is of menstruation and athlete performance. Such issues have not been touched. So there are many issues where design research, when it works on ground field, can come out with those issues, and those issues can drive the technology innovation. So in design, we look at very acutely at the humans and their lives, and therefore we have better eyes to what the problems are. Third is collaborative design. Now, such a health innovation cannot be driven just by technologists alone sitting in the lab. You need stakeholder involvement, you need users, you need experts. So, and the earlier they are set into the motions when you are innovating, the better it is. And design research works on collaborative design, where everything you do, as you will see in the examples, we work together with the experts. It could be health experts, it could be research experts, it could be domain experts, subject matter experts. Multidisciplinary experts work together to get the innovation going at the start. So that is what design research really promotes. Then it is iterative and field testing. That means we drive a very iterative process, which is field tested. We work less in the lab, more in the field. So any of our product, any of our ideas, any of our innovations is directly towards end user and experts. Finally, we have service-oriented mindset. That means most of the products today, most of the technologies today have to fit into the larger system of health innovation where services are offered. So you need to have your technology fit into the system of health decision-making, central systems. It could be patient archiving systems. It could be any system. It could be systems of decision-making which are in certain hospitals or in policy making, but it has to fit into the larger system. It has to offer a service either to the government, either to the hospitals, either to the doctors. Somewhere it has to fit into a service larger. So strategic weaving of solutions. So design research takes into a strategic viewpoint where we see which kind of service can be designed for which kind of users to fit in. And finally, you have streamlining and organizing user-centered data. So like I said earlier, you can create any kind of data, but is it a pure data? Does it have biases? Does it have value for the users and experts? Those are some of the things that has to be considered. And of course, GDPR and many other issues. Can it be shared? Can it be worked? So those are very critical issues. And those are ahead in time, streamlined in user-centered. So we see which kind of data will make value for the users and experts before we even go forward, minting it or getting it out. Because as you all know, technology is expensive. It takes time. So that are the key tenets of design research. And the model that we usually follow is it's also called user-centered design research, but this is also known as double diamond. This is by a model by Design Council UK, but we start with the problems and then we understand the users, we understand the context, we discover it, and we are defining the right thing. So we understand what is the problem, what is the real context, what is the user, and then we go forward exploring it, and then we define our problem. We frame our problem after we have done thorough field research. We frame it together with the stakeholders that this is the real problem that will be of value to the users and value to the health fraternity. And then we start developing potential solutions. We quickly prototype them. We have very low fidelity prototypes that we develop, and then we call upon few users, we call upon the stakeholders, we test it, we listen to them, we understand, we receive feedback, and then we start developing again and again the iterations and we go forward. So it is very iterative, and therefore it leads towards designing things the right way or innovating things the right way, which can make earlier adoption, which can fit into the larger health system. So one of the projects that I've been leading and working is Project Coral. It is available on Android and iOS platforms. It is a decision-making tool for tracking menstrual cycle of female athletes. especially focusing on their performance. This is an issue which has been very, very less touched upon all over the globe. Studies here in Norway and also global showed that this is a taboo, talking about athlete performance and relating it to menstrual cycle. There are female athletes and they don't talk to their male coaches about it. The male coaches are totally ignorant about it, and yet we are fighting, striving to become the best in the world and getting Olympic championships for women without addressing this issue. And therefore, this is a decision-making tool both for tracking and trying to correlate the performance with the menstrual cycle. And I work together with one of the experts in the world. He is the managing director for Center for Athlete Sports. As you all know, Norway is leading in Olympics, Winter Olympics, and leading in sports in so many ways. Sports is a very, very fabric. Like in India, we our our food is so very critical and central to our lives. Sports is very central to Norwegian life, and therefore the center is a leader in the world. And I work with him, and he is the PI for this. He's the expert and knowledge owner of this area. And I work as a co-PI working in design, research and development and testing for this innovative product. We have an innovation leader, Dr. Vikram Singh Parmar. The funder is NTNU for discovery. And we have researchers who are working in redesigning and also in the field study. The aim is to investigate the correlation between athlete performance and MC to get pilot data to build an AI model around it so that coaches can use it for better customizing the exercise duration of MC so that the performance can improve. And the effect of menstrual cycle on physical performance for female athletes is found relevant and is an upcoming area of research and technology development. However, the knowledge about MC effects on exercise and performance has been very limited. Evidence shows that there is a considerable number of athletes who do not communicate with their coaches about MC and hormonal contraceptive use, usually when the coach is male. And the lack of communication could be explained by insufficient knowledge of both athlete and the coach's point. And this is a taboo, and this is global taboo. It's in India, it's a taboo. In Norway, it's a taboo. Worldwide, it is a taboo. So how do we go forward with it? This is a staged, it's a field study. So we develop and design research helps in developing a prototype so that we can run such a study. And therefore, we build a pilot. And stage one is first we run a baseline data for user requirements. We better understand what kind of user requirements which coach and athletes have, go into their lives, better understand how they actually exercise, what kind of training data they record, what kind of value it will add. So we ran focus groups with them. Then we ran focus groups with co-workers and sports and coaching and female athletes. Along with the coaches again, to better understand all the different details of the athlete life, and especially a female athlete life. And we get into the details, we get the data. Next is the concept design. So this particular product, Coral, has been designed by me and developed by Circon, that's a Norwegian company who's developed the prototype for us. And of course, it went into ethical approvals from the Research and Ethics Committee because we are getting into personal data. So this product in particular, yes.
Dr. Parmar, sorry for interrupting.
Yes.
Can you conclude in 3 minutes?
Yes, of course. It's just the last 2 slides. So we get into the details of menstrual data, and we get into the details of analytics of how performance can be correlated with it. And we ran a pilot test with 30 athletes and 5 coaches in a 4-month study to investigate the role of menstruation on performance. As you see, we worked on the baseline, and we also worked on getting the data, the sleep data, the performance data, the menstrual data for all the 3 months. And then we came back with a post-study questionnaire as well as to better understanding of how they value this testing. And this product. Next stage is that we are redesigning the functionality and analytics. And in analytics, we are working closely in correlating how the performance and pain received by the athletes can be correlated. And we are developing further analytics based on it. Of course, 30 users is a very limited users, but it's field study. We are getting the initial studies and we are getting work at it. What is the key findings about it? There was no pattern found between MC and athlete. That means every athlete's MC is very personal, and there are no two athletes where we can see any correlation with. But there were some patterns found in performance and MC, especially related to pain and to sleep and to performance. And those are the ones we are investigating further. Therefore, there is a need for self-knowledge and management tool, and better need for communication tool between the athletes and the coaches. So, and this is a paper in submission currently. We are working on this, and in future we are going to work on second stage development. We have a large hunt database where we have several thousand participants whose blood data and sample data has been collected together with a lot of biological material we have. We are trying to integrate that into it, and we will also integrate IoT. That means we might have a smartwatch which will have some of the sensors which will get data into it, to have a better large scale input. So in summary, what do we say? We say that human-centered technology development is critical when we start involving the athletes and the coaches and start better understanding at the ground level what the needs are. We are better tuned towards innovating things which are service oriented, which are pragmatic, and the data that we collect, or the AI models that we collect, will have better value for optimizing of user problems. Thank you.
Thank you, Dr. Parmar. Is there any question from audience? Anyone has any question for Dr. Parmar? If you can ask.
Madam, what will be the sample size? You had collected the data, no? So what is the sample size?
As I said, this is a field study, initial field study, first pilot. The sample size currently is 30 athletes, but now we are going for a large scale study with a lot of IDRIT schools, that means sports schools, and then we'll have about 1,000.
Okay.
Yeah, because these are female athletes, and I have specially worked with elite athletes. Elite athletes means they are all competing for Olympics or global championships. Elite athletes are very rare all over the world. So we cannot have 1,000 elite athletes in a country. So we have worked with 30 elite athletes for now to get in pure data. And then we are going in for larger athletes for entertainment purposes as well, who are just athletes in total.
Yeah, okay, madam.
Yes, Dr. Surendra, you have question? You raise hand, that's why I'm asking. Dr. Surendra? Okay, Dr. Parmar, I think there is no more question.
Thank you so much.
Thank you very much.
Thank you so much.
For
Thank you
sparing
so
your
much.
valuable time.
Thank you so much.
Our next speaker is ready. That's why I'm little bit in a hurry.
Yes.
So thank you very much. So next invited talk is by Dr. Biplab Banerjee. I would like to welcome Dr. Banerjee to present that talk. Yes.
Yeah. Hello. Yeah.
Yes. You may start.
Yeah, sure. Yeah. So the screen is visible, I suppose, right? So the screen is visible, right?
Yes, everything is fine.
Fine. Okay. Well, first of all, thanks for having me and all the very best to the conference. So I'm Professor Biplab Banerjee, an associate professor at the Center of Studies in Resources Engineering and the Center of Machine Intelligence and Data Science at IIT Bombay here. I lead the Deep Learning and Computer Vision group. So this talk is about some of our recent research on applying advanced deep learning techniques for hyperspectral image analysis. So just to give some context, so hyperspectral images are type of images where we have many spectral bands, typically which ranges from 100 to 200s. So these are, very narrow bands in the visible or the infrared part of the electromagnetic spectra. And given this narrowness of the bands, I mean, these kind of images, they have wide range of applications, starting from mineral analysis, geology, snow cover analysis, and other than that, urban analysis and all the other stuffs. So they are very much rich in spectral properties, and that make them a pretty unique kind of data than typical multispectral or the RGB data that we have. Now, I mean, like any other images, the semantic segmentation problem is pretty popular here, where every pixel, I mean, we have to annotate every pixel to a given set of class labels. Now, for this land cover classification or the semantic segmentation, as I call for this task, there are two possibilities. In one case, we treat each pixel as an independent entity, and we just use the spectral bands as the feature vector and deploy it using any off-the-shelf classifier. But there's some problem with this approach that it does not take into account the neighborhood information, the contextual properties and all. As a result, the output may be a bit disconnected in nature. On the other hand, there is the spectral spatial approach, where both the spatial as well as the spectral properties are together taken into account. And this kind of approaches, they give much more continuous a smooth segmentation map. A typical example of spectral spatial models are like UNet, the SegNet, or the transformer, this kind of models out there. So we focus on the spectral spatial relationship, but we deal with them from three different point of views. So I'll talk about majorly three work out here. The first is the fully supervised model. So here our focus is to learn better spectral and spatial features so that the final segmentation map is enhanced. In this regard, the first work, this is the first work where, what we propose that we first try to disentangle the spectral and the spatial properties, right? So given the hyperspectral data as input, they're passed through two encoders, this SA and SB. And after that, what we do, within this SA and SB, some attention modular fix. So attention is something like a feature weighting module, but here the thing is that the attention weight or this they're learnable in nature, so they're implemented with respect to some fully connected layer followed by sigma activation kind of thing. So we get values between 0 to 1, and we weight the features accordingly. So the first task deals with disentangling the spectral and the spatial features through this attention module. And along with that, what we are doing, if you see the middle this line, so we are just passing the raw patch as well. So we have three sources of information: the raw patch, the spectral attended feature, and the spatially attended feature. But after that, what we are going to do, we are going to combine all the three sources of information using some weights. But here, the main point is that the W1, W2, W3, the three weights, they are learnable in nature, right? So, I mean, we are just putting them as this learnable variable through backpropagation. So they can combine the feature as per, what the task finally needs. Accordingly, these three feature channels, feature dimensions are actually combined. Following that, we just deploy a 3D convolution neural network so that can take the 4D data into account. And finally, with given some combination of cross entropy and dice loss, we can generate the final classification map. So that's the idea. So the main focus is we want to do spectral spatial classification, but we want to disentangle the spectral from the spatial properties, and we want to highlight the more important feature through this attention modules out there. And the next thing is we do this adaptive feature combination where the adaptive weights, the W1, W2, W3, these are learnable. Now, this is how the attention they go on. So as you can see, X is the actual data, and SB, so these are the attention module, and theta being the parameter of the attention module out there. Now, there's another thing that we tried out here. First thing is this weights that I mentioned, W1, W2, W3. So we want them to be a convex combination. So we put the restriction that the summation should not exceed the value 1. And we also put up a regularizer out here. So typically, in a CNN model, the dropout being the most frequent regularizer, right? But it does not ensure any discriminativeness in the feature space that we get finally. So just to enforce the discriminativeness, we use a Weissenstein regularization loss, which says that, the distribution of the samples that should be far away from each other. The inter-cluster separation that is actually ensured by this Weissenstein, this this metric out there. Okay, while the cross entropy loss, the standard cross entropy loss, it enhances the within class compactness. The between class separation is enhanced here through this with a strain loss. So I mean, if somebody has worked with GAN, so you must know that there is this WGAN, the Weatherstein GAN, which is pretty popular in generating images which are diverse and at the same time, that can preserve the semantics. So that was the main motivation of using this loss function. So our total loss is a combination of cross entropy and the Weatherstein loss. So we want to maximize the Weatherstein loss. That's why the minus sign is here. So the total objective is we want to optimize LC given the condition that all the W's they should sum up to 1. Now, here are some results. So, in hyperspectral data, there are typically some benchmarked data sets which are available. So, I'm showing some result on that. So, the one is Houston 13 and the other is Houston 18. So, there are around, you can see how many classes are there and all this thing. So, we show both quantitative as well as the qualitative results out here. And we show comparison with a number of existing techniques, which are there, and most prominent being the 3D CNN, which came just before this paper was published. And as you can see, disentanglement of the spectral spatial feature and the adaptive weighting actually helped us. So the paper could beat the others pretty substantially. One interesting thing to note here is that I mean in this graph below here for the particular class tree, we show the spectral signature in the original spectral channels, and after attention we see what are the channels that are more highlighted, right? So this is the result of the spectral attention before and after the application of this attention. You can see that it actually maintains the spectral curvature, but it highlights unique channels from each of the modes out here. So that is a proof that even if you're learning the attention, but still it preserves the spectral characteristic of the original data. Now there are some ablation analysis. I'm not going into detail, but they're showing like why the ablation this attention is important or not. Like what happens if we add this whether strain loss regularizer or not. I mean that kind of proves that all the modules are pretty important here. Now in the next work, I mean what we tried, so typical, so this is called we introduced something called a feedback loop neural network, hyperloop net. So typically when you see a neural network, so this is a feed forward network, right? So the information propagates into a single direction, and as a result what happens that more deeper layers they can encode more high level and semantically more richer feature compared to the lower level. So, but I mean that will all. So as you make the model more deeper, it theoretically suggests that the network is going to perform well or learn better feature. But this is very difficult for the deployment point of view, right? Because for deployment we want a more concise network out there. So with that idea is in mind, and there's another important aspect which says that I mean just to encode the spatial information, right? So what should be the optimal kernel size, right? Because for some pixel a bigger context may be useful, for some other pixels a smaller context might be useful. So a better way to deal with this is to use multiple context size at different scales. Okay, for example this 3x3, 5x5, 7x7 all together, so that we can actually use the important information from all the context size that are there. Anyway, so now coming to this idea of hyperloop net, so what we do basically, we want to kind of distill the information from a deeper layer to the shallow layer. Okay, so it's not only a feed forward connection, but there's a feedback connection where we try to tune the property of a shallow layer based on the feature that are learned in a more deeper layer. Okay, and so it follows this self-looping structure. So all the I mean if you see each block, so every layer is connected with all the other layers, that makes the feature dissimulation much efficient in this case. Okay, and we repeat the same thing for different kernel size, 3x3, 5x5, 7x7. That gives us some feature tensor of equal size, and subsequently we just pool them using a global average pooling layer followed by a softmax classification, and we get the predicted map. Okay, now, when we see how this performs, like the idea of this feedback looping for better feature learning, so we say that here we did a bit more extensive experimentation out here. So we can see that this model is actually pretty good, and it can beat even advanced model like OctaveNet, or there's a wavelet CNN based approach out there, this LWTNet, even in most of the classes. Yeah. So this Houston's are pretty challenging data because I mean the spectral difference between the classes are pretty narrow and all this thing, but still this model, the hyperluminate, was able to do better for both the data sets. Okay, and another important thing is that here we show the time and the complexity of the models, and you can see that I mean the hyperluminate, it only requires 350 millions of parameters, and it has much faster inference time than most of the other models out there. Okay, so that is a proof that so with this feedback, this feature propagation, we can do faster inference. Now moving forward, so but the previous two things were fully supervised models. So now we want to reduce the number of label data and still want to achieve performance of a fully supervised model. So typically a few shot kind of scenario for hyperspectral image classification. So in this case, we proposed a network which is called stable prototypical network. So typically what happens if you have less amount of training data, so the model actually overfits, right? And model overfitting means that on the training samples, the model become overconfident for prediction. So we want to tackle this problem through the notion of uncertainty. Okay, so what do we want to do? We want the model to learn the features episodically, typically what is done in meta learning, and at the same time we want the model to be very confident in certain prediction. Okay, so which means we want to reduce the uncertainty of the model in the prediction out there. So we propose something called this network, which is the stable prototypical network. And here, in order to incorporate this uncertainty, we make use of the layer called the drop block. Okay, just to give some context. So in dropout, what we do, we just randomly put off some nodes in the network just to ensure that the model learn more holistic feature. But in drop block, what happens, instead of randomly moving out some independent nodes, we move a patch, all the nodes corresponding to a patch. So this is important because when we deal with images, the patches, they have more important information than individual pixels out there, right? So that's why we propose this drop block, this notion. I mean, in every iteration of my training, some patch, some blocks are actually dropped, but the other blocks are actually on. So it works in that way only. So this is the loss functions. We have the typical, metric loss, which ensures that each data point should be closer to the corresponding class prototype, the class centroid. And along with that, what do we want? We want the variance of the prediction to also being minimized. Okay, so we have two loss component. One is the cross entropy loss, and the other is the variance loss that ensures that the model should predict the same feature or same prediction irrespective of how many times we feed forward the data out there. And here you can see that some result, like if we use only one training sample per class, the model gives an overall accuracy of 80%, which is pretty amazing, right? And as we increase the number of training data, for example 15 training sample per class, this is giving almost 99% of overall accuracy on the very popular Indiana Pines data. Anyway, and here in below we show the why this dropout is important and why drop blocks is even better than dropout, things like that. So the point is, with very few training samples also we can reach accuracy of a fully supervised model. So that was the main idea. So we just tackle the overfitting through the notion of uncertainty optimization. Now, finally, the last work that I'm going to talk about. So here, although we deal with a supervised case, but it may happen that we train a model on some classes, data from certain classes, but during deployment, the model may encounter samples from classes which are not seen during training, right? So this is the notion of what we call the open set recognition or outlier detection or out of distribution detection whatsoever. So in the final work, what we have done, we propose a new problem definition called few shot open set recognition. Okay, where on the known classes, on the training classes, we have very few training samples, but during testing, in the test data, we may have sample from either from the known classes or from unknown classes. So what we have to do, given the test data, we have to either classify as one of the known classes, or we have to say that this is unknown. So reject those samples out then. So this is a typical scenario of few-shot open set classification, because I mean, if you see the Pavia dataset, the typical Pavia data, so all the black pixels are actually unknown class pixels. They are not labeled in the ground truth. Okay, so we want to properly classify all the colored these pixels, and while rejecting any pixel coming from the black area. So now I already mentioned the problem setting. So we propose something called OCN, outlier rejection network for this purpose. And again, it's a meta learning based approach. So the model become more generic in that sense. So what we want two things together. First of all, we want to hallucinate some unknown class sample given the known class data, and we applied some generative model for this purpose. I'm not going to the detail; it can be found in the paper. But I mean, we want the synthesized outlier data to be a bit different in properties than the known class data out there. And the second thing that we want for the known classes, we want the feature space to be very discriminative in nature, right? So there are two objectives. So how can we ensure that we seamlessly generate the potential unknown class data, and at the same time for the known classes we want a very compact feature space out there. Okay, and if we can do that, subsequently we can train a classifier that can separate out the known from the unknown pretty easily. So that was the main idea for this model. So this is the overall architecture. So the VAE part does the unknown data synthesis, and then we have the unknown and known class data together, and then we just have a classifier, what we call the outlier calibration network. It's a binary classifier kind of thing. So that optimizes the confidence of the known or unknown class prediction out there. Okay, and if it is known, then of course it may belong to one of one of this known categories. But if it is unknown, just unknown. That's it. So, and of course, we propose something more because we are dealing with hyperspectral data. So we just tried to, improve some spectral spatial feature learning through attention module. For example, here we propose something called this ART3CBAM, a new attention module out there. So it looks somewhat like this. We have the patch. First, we apply the spectral attention module, followed by spatial attention module. It's a sequential attention learning process out there. Now coming to results, so here typically for this kind of task, we have to show the accuracy on the known class set, we have to show the accuracy on this unknown class set, and the some sort of AU-ROC curve or the harmonic mean between them. And you see here, this is the one-shot result. So for the known classes, we have only one training sample per category, right? So you can see that the model actually did pretty well with, I mean, that much amount of less training data. And if you increase the number of training sample to 5 per class, then you can see that the performance even improve further. Okay. So these are some visual result, and you can see in the last one is our result, and it actually can produce result comparable to a fully supervised case, right? And while rejecting all the outlier sample pretty easily. Fine. So in conclusion, I can say that, of course, hyperspectral image analysis is important, and what is more important is to process them using a spectral spatial this approach. And nowadays, people are moving from the fully supervised to a few shot or few shot open set, this kind of more advanced paradigms. And but the goal is to achieve accuracy which is at par with the fully supervised accuracies out there, and that itself brings in novel avenues in the future, both from the application as well as the algorithm design point of view. Because for example, how will you deploy all this thing in a transformer, right? So how can you leverage the self attention, cross attention modules of the transformer? So those are very intricate questions. So the three works that I mentioned, so they are specifically from these papers of ours, and these are particularly of the PhD students Shivam and Devabrata, so who worked on these problems. And yeah, that's it. So any question you have, I hope I'm on time.
Yes. You are.
Yeah. So any question?
Any question from audience?
Sir, one question.
Yeah.
Sir, as you told about a few short open set, right, for unknown classes.
Yeah.
So what about clustering? Can I use clustering methods
So
in
that
that? Can I use
yeah.
LBA?
No, actually, that's not. I mean, there are two kind of problem. Okay, so
Yeah.
typically, I mean, till 2022, I mean, when you say open set, I mean that means all the open sample should be classified into a single class. Okay, but in 2022. A very popular paper came, which is called generalized category discovery. Okay, so the class discovery problem. So where, I mean, people are moving inside this open set and try to see how many clusters are there. Okay, well, just applying simple cluster won't be of help, because you have to estimate how many clusters are there, right? And that is something that we do not know. We just know that these are unknown samples, but within the unknown samples, how many clusters or classes are present, that is unknown to us. So that's why, like, I mean, of course, subsequently there are many works on this class discovery. So maybe you can look into that literature.
Yeah. Okay, sir. Thank you.
Yeah.
Anyone
So
else? Yes, Dr. Banerjee,
Okay.
thank you very much.
Yeah, thank you.
There is
Yeah.
no more questions.
Sure. Thank you. Thanks a lot.
Thank you very much.
Yeah.
So we have next technical session, that is S4. The session chairs are Dr. Gabriel Gomez Oliveira and Dr. Aditya Sastry. Dr. Oliveira from University of Campinas, Brazil, and Dr. Sastry is from PDU Gandhinagar. So I welcome both of you, session chairs, and hand over this session for you.
Thank you, sir.
Hello.
Yes.
You listen to me, Professor?
Yes.
Oh, thank you so much.
So may I call the author or you are calling the author? Do you have the paper list with you?
Yes, I have.
So I hand over this session to you. So you are the chair of the session.
Ah, okay. Professor Edith, you possible I start?
Yes, I think you can start the first one. Yeah, you can call them.
Okay.
I'm just finding the list of the participants.
Okay. Thank you so much. Professor Patel, it's possible to start at the moment?
Yes. So
Okay,
first paper is 30.
Okay. 030. Okay. Mutual disclosures prediction using assembling of a distinct machine learning and deep learning classifier.
I think author of paper 30 is present here. By Venkate. Okay. So you are the presenter. So you.
Yes,
you
yes,
can
sir. Yes,
share
sir.
this.
Yes.
Okay.
Good afternoon, sir.
Good afternoon.
Yeah. Okay, sir. Can I share my screen, sir?
Yes, you can.
Okay, sir. Thank you. 1 second. Sir, is it visible, sir?
Yes, everything is fine.
Yes.
You can start.
Okay. 1 second. Good afternoon, everybody. And myself, Venkat Chaudhary B, and I'm a research scholar in SRM University, and I joined recently, and just 1 year back. And my title is multi-disease prediction using ensembling of distinct machine learning and deep learning classifiers. So these are all my contents in my presentation. That it's abstract introduction, literature review, and proposed methodology, data set and data pre-processing, outlier detection, ensembling, and finally result and conclusion and some references. Yeah, this is the abstract of my presentation. Generally, this is a multi-disease prediction, and we start with the diabetes. Okay, and generally we know everybody it is a very chronic disease, and due to some blood sugar issues. So in nowadays, by using this particular data set, and we apply some machine learning standard machine learning classifiers. After that, we use that ensembling. It means in the while we are ensembling that, we use the some hard voting and soft voting classifiers that we will discuss it in that result section. And this is about that our abstraction and introduction. When comes to the introduction, as of now, so many people, most of the people from by birth to the old age peoples, all the people are suffering with this diabetes. But along with this diabetes, we tested our model with some chronic kidney disease CKD data set, and that will be will discuss it in that particular result section. And this is about my introduction regarding this multi-disease prediction and literature review. So for when coming into the literature review, and we reviewed so many papers for preparing and for this particular manuscript. So out of this one, based on our data sets, it means that diabetic data set and chronic kidney disease data set, we gone for that particular by using machine learning techniques, and yes, we proposed some approach by using that ensemble one. And this is the our proposed methodology, and this is the core key part of our work. So here data set, and here we used two data sets. One is that PAMA diabetic data set, and one is that particular CKD chronic kidney disease data set. So after that, selecting the data set, and we the next phase is data pre-processing. Okay, so in that data pre-processing, just outlier, just we use that some outlier concept while in this particular outlier analysis, and we used that particular DB scan clustering. And after that, next phase is pre-process the particular data, and at the same time, generally we train and test our data. Generally we use that particular 80% training data and 20% testing data scenario. And these here we use the three machine learning based classifiers. Those are the decision tree and the logistic regression, and that third one is the neural network. Okay. So by using these three machine learning classifiers, based on these three machine learning classifiers, by using the grid search, and we hyper tune that particular base classifiers. So after this process is completed, then we use ensembling by using that voting rule. Here we use the two types of voting rules. It means that is hard voting and the soft voting. So after voting rule, by using that particular hard voting rule, and we ensemble these three machine learning based classifiers, and at the same time, for the validation purpose, we use that k-fold crash validation. And after applying this particular k-fold crash validation, so model testing and our performance metrics are generally accuracy, precision, recall, and F1 score. Is our in our work, those are the performance metrics. So, and this is about my proposed framework. And when comes to the next slide, here some description about the particular data sets. So already we discussed that we considered two data sets, and PAMA Indian diabetes data set and CKD. So for that particular multi-disease prediction point of view, in this particular PAMA data set, there are 768 records, 768 patients along with totally 9 attributes. In that 9 attributes, one is the class attributes, so 8 attributes is there. And this CKD data set, there are 400 records, and that 25 attributes is there. When it comes to the data pre-processing, so we already discussed about what we followed in that particular data pre-processing. Generally outlier for in purpose, we use that particular outlier concept. So here why? Because this PAMA data set is having the more number of missing values. That's the one of the main reason for selecting this particular data set while we solving our multi-disease prediction. So for filling out that particular missing values, we use the some mean and median of the particular attributes. And finally, the outcome is either that particular is there diabetes is there or not. It represented with the 1 and 0. And these are the this figure number 2 represents the distributed between the diabetic and non-diabetic patients. It means red color denotes the 500 and this green color denotes the 268 people. And when comes to the outlier detection and analysis, so this is the one of the key component in our work. So here this pair plot diagram and the correlation diagram for this particular PAYAMA data set. And here we use that particular DB scan, density based clustering, for solving this particular outlier detection in our framework. So here the figure 3 represents the pair plot and the figure 4 represents this particular correlation matrix of the particular PAYAMA data sets in this particular concept. And so when comes to the ensembling, it means here we ensemble the base classifiers by using and hard voting and soft voting rule, and this is the formula for argmax 1 by capital N into, and this is the formula which we followed for this ensembling, and this is the main results part of our section. So already we discussed, and left side the table 1 represents the shows we used the 2 data sets in this particular concept, and the first one is the PAYAMA data set, and second one is the chronic kidney diseases, and the these first 3 are decision tree, logistic regression, and neural network. These 3 are the 3 machine learning base classifiers. At the same time, we use the hard voting rule as well as the soft voting rule, and these 2 votings applied for the both data sets. These 2 hard voting as well as the soft voting are included in our framework. So when observing this particular table, so this PAYAMA data set got the accuracy of 75 for the hard voting rule and 74.78 for the soft voting rule. When comes to the chronic kidney disease, and while we are using the hard voting rule, and it gives the 93.75 accuracy, and when we use the soft voting approach, it gives the accuracy of 98.75. But when comes to the recall, why? Because in medical point of view, recall is the main performance metrics than accuracy. So when comes to the recall, and for the PAYAMA data set, the decision tree gives the most recall value. Sorry, that hard voting rule gives the most recall value. That's the almost 76, almost close to the 77. And at the same time, the soft voting gives the very low recall value. That is 30, almost close to the 35. And when comes to the chronic kidney diseases, the recall, the most recall value gives the base classifier decision tree 98.08, as well as our proposed soft voting rule. It also gives the 98.08. And the right side, when right side of this particular side, and these are the result comparisons between the chronic CKD data set and the PAYAMA Indian diabetics data set. And the last 2 represent the first one, HV means hard voting, and hard voting results of the performance metrics of the when we apply the hard voting rule and when we apply the soft voting rule on the corresponding data sets. And this is about our results. And then next, when comes to the conclusion, so while using other than the standard machine learning techniques, so we providing the better path, as it means getting the better results while we are applying the ensemble things on this particular data set. It means PAYAMA Indian diabetic data set and CKD data sets. So when it comes to the validation, we use the k-fold cross validation, and so the machine learning base classifiers are hyper-tuned. I already discussed while in that particular while we're discussing about that framework. So we use the grid search for hyper-tuning. So, and that's about the conclusion. And these are the some references which we while we read as part of our literature review. And that's all about my presentation, and thank you very much.
Congratulations for a presentation.
Thank you, sir. Thank you very much.
Thank you so much. At the moment, I start for question for lectures. Okay.
Yeah, sure. Sir, can I stop the presentation or like?
Yes, please.
Oh, I think yeah. I just have one small question. Yeah. Can
Sure.
you go to the slide where you have shown what the different classifiers you have? The three
What, sir?
classifiers.
What, sir?
The three classifiers that you have used. So can you go to that particular slide?
This one, sir.
So my very simple question: you have selected these three classifiers: decision tree, logistic regression, and hierarchical. So is there any particular reason that you have selected only these three and not the others available? I mean, why only these three?
No, sir. Actually, there is a chance of using the other classifiers in this same point of view. But as per our literature review, just we choose that this particular point of view based on this multi-disease prediction for while we are using this particular data set. Of course, there is a possibility. I am sure, and I will be use the other techniques in that my further works.
Oh, okay.
Thank you.
Okay, fine. So just one more suggestion I have, not the question. You go
sure,
to
sir.
your slides, result slides.
1 second, sir.
So I can see here that you have given results for your two data sets, PID and PKD. Okay. And the results for your two ensemble models, right? Your hard voting rule, soft voting rule. Okay, but I do not see the comparison of your results with the existing work. So did you do that and not included here, or that? Did you compare your work with the existing work?
Yes, sir. But some due to constraints of this paper, this kind of paper, so I am not able to insert that comparison here, sir.
Okay, but you did that, right?
Yeah, I did, sir. Actually, that extension also it's already started. We will sure that we will success.
No worries, because that will show the importance of your work, right? Because if you compare your work with others, then that will be.
Yes, sir.
Okay, so congratulations, Venkaya. So I think that's it from me, sir. Gabriel, sir.
Thank you, Professor. I have one question.
Yes.
My question is reference the 768 peoples. It's the family patents, okay? You put yes, the 7th page. Yes. I have it's the number. It's only family. Don't have men's or it's why is only family?
Yes.
I don't understand. Sorry.
Sure, sir. I will answer this question. Sir, actually, when comes to the main reason for selecting this particular data set, this is having only that female diabetic patients while they're having some during the pregnancy time. So this is the key data set from previous days onwards in the diabetic prediction. But recently, 2 weeks before, I found 2 more diabetic data sets, and I am trying to insert those in extension of my work. Why? Because this particular data set is having the more number of missing values first. That's the main reason for selecting this particular data set.
Okay, and have you second questions for start this point. your imaginations and the future use other data sets for comparisons, the demands and the families. And my third questions, no questions, but observation, it's more datas, okay? I think it's 700, it's good number, but more 100, 200, I don't know. It's, I think the result is it's more good for more specific because have more data, right? Do you understand?
Yeah. Can you?
See, okay.
Yeah.
My questions, it's I think it's the use more data, okay, more data for analyzations. Your result it's more good because have more data. I think it's 700. So 700, it's good data, but I think it's good idea for you use more data than the future works. And my second and
Sure, sir.
you
I
can
understood, sir. Now understood clearly.
okay. And my second point questions, I think you in the future work you use it the other data sets or no?
What, sir? In the future?
In the future work, you use it other data sets for comparisons, or do
Sure,
you
sir.
have good ideas
Comparison
for
issue in
future?
the future, compulsorily I will add that comparison. Then only we can defend how much our work is more effective when we compare to the other.
Okay. Congratulations. Thank you so much. It's possible.
I think we need to move to the next paper.
Sir, 1 second,
Yes.
sir. I will stop. 1 second, sir.
Okay, so paper ID is 83. Author of paper ID 83, are you there? Yes, so you are the presenter, so you can share your screen. Laksita. Please share your screen. Laksita. Are you facing any difficulty? Yes, it's okay. Yes, you can. Yes. So turn to the presentation mode. Okay, fine. Everything fine. You may start.
Please start, Lakshita.
Just strictly follow the presentation guidelines. Huh? You need to complete your presentation in 12 minutes. Laksita, you may start. Go to the presentation.
She's having voice issue.
Yes. So meanwhile, yes, okay. Yes, you can start, Lakshita. We can see your presentation screen. So shall we move to the next paper? Meanwhile, Lakshita, be prepared for the presentation. Then again, you will present after the paper ID 201.
Paper
Author of,
ID 201.
author of paper ID 201, are you there? Yes, he is. Yes, okay. So let me make you the presenter. Yes, you are the presenter, so you can share your screen.
Okay, thank you. Am I audible?
Yes, you are
Okay.
audible. You can start your presentation.
Yes, I'm looking for the slides. It doesn't appear. Anyway, I'll just share the entire screen.
You need to choose the window.
Yes, from the window, there's only the 3 applications. I don't know why.
Maybe, or you can share your screen.
Okay, I'll just share the entire screen.
Yes, it is visible.
Okay. So, good afternoon, everyone. I am Maureen Olive Gallardo, a doctorate student at De La Salle University, Philippines. I will be presenting our paper on online health information seeking in social media. This research was conducted with my co-author, Dr. Ryan Ebardo, a faculty of De La Salle University, who is also with us in this online presentation. Now, one of the information individuals seek on social media platforms is on health-related topics. Along with the continuous evolution of these social media platforms, it is also the elaboration of how individuals see and share health information. And because of the recent COVID-19 pandemic, online health information seeking has increased, especially in social media. Thus, with the popularity of these platforms and the increasing prevalence of health information seeking, it was crucial to conduct a systematic review in the field. In this presentation, we will address the following research questions. Who uses social media for health information seeking? What platforms are utilized by these individuals? What are the features of social media that facilitate health information seeking? What are the motivations of individuals using these platforms, and what are the possible concerns? In conducting the systematic literature review, we selected Scopus, PubMed, and ScienceDirect databases using the search keyword online health information seeking and social media or social network. The search on each database resulted to the following number of records: 60 from Scopus, 40 from PubMed, and 152 from ScienceDirect, with a total of 252 records. Since the records were collected from 3 databases, duplicate copies were removed, which is a total of 47 records. Then the 205 unique records were screened based on title and abstract and excluded 75 records for the following reasons. First, it did not have the keyword social media, social network, or health information. It was a review article or commentary, or the abstract was not available. And based on this screening, the resulting 130 records were further screened for eligibility based on the abstract and full text of the articles. 106 records were further excluded since the full text was not available or not relevant to the health information seeking in social media. This resulted to 24 studies, which served as the final list for the review. Based on the 24 included records, these are the characteristics of the studies, which span the last 10 years from 2013 and up to some studies in 2023. The prominent approach is quantitative on 16 studies, followed by qualitative approach on 7 studies, and one mixed method approach. The data that were analyzed in the included records were mostly collected from educational institutions, general population, outpatients, and gender-specific respondents. Only 5 studies collected their data from posts on social media platforms. Lastly, in terms of the context of the studies, 15 studies discussed how social media facilitates health information seeking. Then less than half of this number is focused on the factors affecting health information seeking, specific social groups, selection of health information sources, information-related factors, and respondents with specific health conditions. To answer the first research question on who uses social media for health information seeking, collectively, the 24 studies identified 13 characteristics of individuals that influence their health information seeking behavior. The characteristics that are supported by most number of studies are age, gender, education, and health condition. Individuals who have higher tendency to seek health information on social media platforms have one or more of these characteristics. Younger age, female, higher education, higher income, living in urban or suburban location, higher health literacy, higher health efficacy, having family members with health condition, having a regular health provider, and reporting health insurance coverage. From the included studies, there are mixed results on marital status and health condition of individuals. Moreover, several studies say that the race or ethnicity of the individual is a factor in the tendency to engage in health information seeking. For the platforms utilized for health information seeking, social networking sites or SNS and YouTube are the most popular platforms. SNS is the top preference, but among adolescents, YouTube appears to be the most widely used. Other social media platforms include social Q&A websites, blogs, forums, wiki websites, and photo sharing platforms. It is also notable from It is also notable from included studies that messaging applications such as WhatsApp and WeChat are also widespread for health information seeking. In choosing a social media platform, studies show that it depends on the type of search task and the kind of information individuals seek. Social Q&A websites and SNS are mostly used for factual and personal experience search tasks. Furthermore, individuals with holistic culture usually seek experience-based health information found in blogs, SNS, and social support groups, while those with analytic culture seek expertise-based health information. For the third research question on what are the features of social media that facilitate health information seeking, we categorized it into 3. The design and features of social media platforms allow health information seekers to engage with others to receive context-specific information, access to various information sources, and inquire anonymously. Context-specific information is acquired through posting and receiving comments, hashtags, and related posts applied by algorithms used in social media. With the diverse users of social media, health-related questions can be asked from healthcare institutions, health experts, and other users. Also, through the follow and subscribe functions and sponsored posts, users can access posts from these different sources. And lastly, allowing users to ask questions anonymously on social Q&A websites is another feature that encourages health information seeking on topics that the users are shy to ask about. As for the motivations for using social media, the apparent reasons are social support, convenience, and access to trusted information sources. Emotional and tangible support stand out from the different studies. Emotional support is predominant among SNS users and social Q&A websites. During the pandemic, users received more tangible support from empathetic crowds, such as taking them to hospitals, helping them with their medications. Also, being able to use social media anytime and anywhere increase the convenience of getting real support. The convenience that motivates people is being able to get the needed information immediately when they don't have time to visit the health professionals and when there is difficulty or long travel time to access healthcare resources. And finally, people contributing to social media are perceived by health information seekers as trusted sources who are not driven by any agenda, especially during the pandemic where health information seekers relied on their preferred platforms as there was mistrust in businesses such as pharmaceuticals. Besides, there were health professionals on the social media platforms such as WebMD and YouTube who spoke about illnesses and how to handle them. However, the use of social media platforms for health information seeking is not without concerns. To answer the last research question, the 24 studies pointed out challenges that we categorized as unreliable information, widespread misinformation, and anxiety. The quality of health information in social media varies depending on the topics, and not everyone verifies health information that they see. Adding to this concern is that health organizations are not able to exploit the use of social media to its optimum to spread more credible health information. In social media, misinformation can quickly spread as most individuals share information without checking its accuracy. For example, based on the study of Iftikhar and Abba Al-Khail, only less than half of the respondents ascertained the credibility of health information. Another concern is the anxiety experienced by health information seekers. As information trust in social media increases, it may also trigger more searches and intensify the sense of distress and confusion that will eventually lead to cyberchondria, which is an excessive online search accompanied by increased feeling of anxiety. Now, from the review of the 24 included studies, we present our key findings as the following. So first is that existing literature is concentrated on the usage of social media platforms and the factors influencing or motivating the health information search. Second, health information seeking in social media is influenced by several factors such as characteristics of health information seekers, type of search task, type of information sought, motivations of information seekers, and the affordances of social media platforms. And lastly, concerns about health information seeking in social media are the unreliability and appraisal of health information and the possibility of anxiety that is triggered by repeated searches. The result of this study implies that the number of studies that examine information-related activities and characteristics is limited. Thus, more studies on these topics would be a good contribution. Also, with the increasing information trust in health information in social media and less verification of this information, studying the anxiety caused by these searches on the platform could be one of the future directions. Second, social media is a broad category of internet-based application with an elaborate environment accommodating the participation of many users. Different types of social media platforms offer unique features and affordances that analyzing the contents and interactions can give more insights into the actual use of these platforms for seeking health information. And the practical implication of this review is how our health organizations and professionals should maximize the use of appropriate social media platforms to spread verified health information and maximize the engagement considering the media type, information type, and target audience. So in conclusion, this study systematically reviewed existing research on online health information seeking, providing a landscape of what has already been done and insights on what could still be done. More studies are still needed to provide insights on the adoption and non-adoption of social media for health information seeking that first, employ the qualitative or mixed method approaches for in-depth understanding. Second, analyze social media content and interactions. Third, focus on information characteristics and validation. Fourth, investigate cyberchondria in social media. And last, get the perspective of different social media groups such as adolescents, older adults, and those with specific health conditions. And I would end this by saying that the continuous evolution of social media and increasing usage also entails continuous research for new knowledge and perceptions on the behavior of social media users. So thank you for your time and attention. Good afternoon.
Thank you so much. At the moment, I'll start for questions for lectures. Do you have? Any have? I have one question, dear. Congratulations first, congratulations for work. And you possible put your screen in the page 2 for me?
Oh, okay.
Thank you so much.
Page 2.
Page 2, please.
Oh, this one.
Yes, this. My question, it's basic. Why did you only use these three data sets? I view use Scopus, PubMed, and Science Direct. Okay, Scopus and Science Direct it's the biggest in the world for in the case for research, and PubMed because it's a reference the health. Okay, but have you others? It's good data sets for example E3Z, ACM, and others. And I have one other. I have questions. Why did you only three? It's you possible explanation for me? Thank you.
Okay, thank you for the question. So for this review, we chose to use three databases because when we reviewed existing literature review, these are also the most common databases that they use. These are reviews also that are health related, and also since most of it, when you say health information seeking, this is mostly found in databases that are health related. That's why we have PubMed. And for other databases that you have mentioned, I think the issue there also is on the access to the database. So far we have these three databases, and also in reference to other existing literature review, we also we use this. We chose these three database.
Okay, I understand. Thank you so much for clarification my question. Professor, do you have one question?
Yeah, a very generalized maybe. Maureen, can you please tell me, I mean, you have said that reliability of information is an issue here, right? So if I search anything onto the social media related to anything, any health information, and if I find that particular information, so how do I know whether that particular thing is correct or not? So do we have any measure for that to know, check that information?
Sir, sorry, sir, I cannot make out the words. Can you
Dr. Sastry, your voice is not coming clearly, so don't move when you speak.
Hello.
Yes.
Okay. So, Maureen, my question is very simple. I just want to know how can we check whether some information onto the internet is correct or not? Any information related to health, because reliability is an issue, right?
Yes, reliability is an issue.
So how to
can you
check whether
verify the
information is correctness?
Is it right that you're asking how we can check the reliability of information from the internet?
Yeah. Yes.
Oh, okay. Since this is our study is a systematic review, so our data are based on existing studies. But so far, based on the reviews that we have, based on the papers that we have reviewed, that is one topic that was not that was not widely explored. But I guess that since that is one of the recommendations also of this review, that would be a very good research opportunity that we can address in some studies later.
Okay.
But personally, if I'm going to personally, not on the research, maybe you can compare sources. So maybe there are other studies that does that, where you compare different information just to verify the content.
Okay.
Okay, so I
Fine.
hope
Thank you.
I satisfied.
Yes.
You were
Yes.
satisfied with my
Yes,
answer.
Maureen. Yeah.
Okay, thank you.
So can we
Thank
move to
you
the
so much.
next paper? Dr. Vasan, are you there?
Yes, sir. Good evening. Good afternoon. I'm there.
Okay. Let me make you the presenter.
Yes.
Excuse me, sir.
Yes.
Am I audible? I'm Lakshita.
Okay. So Dr. Vasan, can you wait for this presentation?
Okay, no problems.
Okay. Yes, Lakshita. Just a minute.
I'm audible, right, sir?
Just a minute. Let me make you the presenter.
Okay.
Yes, you are audible. You can share the screen.
Okay, sir. Okay, sir. Sir, am I audible?
Yes, you are audible. Go to your presentation screen.
Sir, screen visible?
Yes. Turn to presentation mode and start presenting.
Okay, sir. Thank you. Shall I start?
Yes.
Yes. Okay. Thank you, sir. Good evening, all. I am Lakshita SL from Sardar Patel University. My paper title is Designing AI-based non-invasive method for automatic detection of bovine mastitis. This is outline of my paper, introduction, related work,
Just a minute, Lakshita. Dr. Sastri, can you see the presentation? Her presentation?
No, sir.
Oh, that's a problem. Okay, just a minute.
Okay, sir.
Because I can see, but others cannot see your presentation.
Okay, sir.
So what can we do? Because your screen is visible to me, but not
Yes,
visible
sir.
to others. Okay, now it's visible, I think. Dr. Sastri, now it's visible, huh?
No, sir, not to me actually. I think I'll leave and join again.
No. Problem is not from your side.
Okay.
Dr. Olivera, can you see the screen now? Gabriel?
Yes, Professor, sorry.
Can you see the presentation of this author?
Yes, it's
Okay,
possible.
okay, Lakshita, continue, please. Sorry, sorry for interrupting.
Okay, sir. It's okay, sir. This is outline of my paper, introduction, related work, architecture of the system, experimental analysis, evaluation of classification, results, conclusion and future work, acknowledgement and references. This mastitis is an inflammation of udder in a dairy animal that is caused due to microbial infection. Milk obtained from mastitis infected animals has several food safety concerns. There are 3 stages in mastitis. There are subclinical mastitis where farmer is not able to identify the disease as there are no physical symptoms, and there is a slight increase in temperature in key parts. And second one is clinical mastitis. Farmer can able to identify the disease as there are some physical symptoms like swelling of udder, watery appearance of milk. And third stage is contagious mastitis. It is an extreme case and the swelling of udder is in its peak, and we may observe blood or clots, pus in milk. And there are many methods like electrical conductivity, California mastitis test, and somatic cell count being presently used by dairy industry to diagnose mastitis. The disadvantage of these methods are they are time consuming and they require high-end equipment and they require skilled manpower. prevalence of mastitis across the world and in India is very high. The annual economic loss is approximately 7,000 crores in India, and it is approximately 32.2 billion USD in across world due to mastitis. Hence, early detection of mastitis is very much needed. Infrared thermography is an emerging non-invasive tool to predict diseases in humans and animals. IRT coupled with machine learning algorithms has potential to detect bovine mastitis. ML algorithms are used to classify the thermal images of udder and eye of the cow to diagnose different stages of mastitis based on temperature threshold. The target detection algorithms like you look only once
Laksita,
ASEAN.
Laksita, sorry for interrupting.
Sir.
Currently, your screen
Yes,
is
sir.
on introduction.
Hi. Yes, sir. I'm explaining
Okay.
introduction.
Okay, no problem. So a little bit fast, huh?
Okay, sir. Okay.
That's fine.
Yes, many target detection algorithms are explored for identification of key parts of animals. And however, there are many challenges while diagnosing bovine mastitis. They are IRT with ML. By using IRT with ML, we have lack of freely accessible datasets of other thermal images and lack of standardized thermal image acquisition procedure, and thermal camera features, operator position and placement of animals and types of milking also affect the reading. Related work in the detection of mastitis. Research carried out by using thermal images coupled with machine learning shows foundation for diagnosis of mastitis accurately in early stages. Udder is a crucial part for detection of any febrile disease by a non-invasive method. There is a significant relationship between udder left and right udder skin surface temperature and ocular surface temperature, that is eye temperature, and udder skin surface temperature difference that is considered for automatic mastitis detection with deep learning methods. And IRT in conjunction with machine learning tools is a promising technique for predictive and precision farming. This is architecture of the system. To make the model robust and by considering the limitations in the field, we have conceptualized the model in three major phases. The phase one is data collection and pre-processing, and phase two is automatic disease diagnosis by training machine learning model with good data set. And the third phase is to fine-tune the decision of classification model using domain heuristics stored in the form of fuzzy rules. Let us discuss these three phases in detail. The first phase is data collection and pre-processing. Thermal imaging is a process of capturing image of an object by using heat radiation emitted by that object. It shows how temperature variations are distributed throughout a scene as observed by a thermal camera. Thermal image of an animal's udder is captured, and the temperature reading represents pixels in the thermal image. The captured image may be noisy due to some atmospheric factors, so pre-processing is required to remove the noise, and segmentation is also required to extract the region of interest like udder, head, or eye of an animal, along with minimum, maximum, and average temperature of the udder. Demographic information about the animal such as breed, age, stage of lactation, milk age, and type of milking, like whether it is automatic or manual, is collected from the field for predicting disease. Also, milk samples are collected parallelly for measuring somatic cell count or doing California mastitis test to train and assess the model output. And the second phase is to train the model using pre-processed images. The information from the original dataset can be summarized by eliminating redundancy using feature extraction techniques in machine learning like feature pyramid networks and path aggregation networks. The data obtained in the previous stage is used to train the supervised machine learning algorithm for classifying the disease. In this case, we have binary classification with two classes 0 and 1 indicating whether the animal is affected by disease or not respectively. The trained model is used to classify thermal image into non-mastitis or mastitis. The third phase of the model fine-tunes the classification using domain heuristics stored in the form of fuzzy rules. Different forms of knowledge about the problem are represented using fuzzy logic, and fuzzy rules are designed in the form of if and then rules. And here are some examples. If the condition says that if the weather is normal, if cow is having subclinical mastitis with low temperature, then advice to farmer have to put some ice packs on order as a home remedy. Similarly, we can store many more. Experimental analysis. For experiment, data is received from Bolanos J et al. And features used for the experiment are temperature, milk yield, mean, median, and mode, minimum and maximum temperature, and thermal humidity index. Data sets are divided in the ratio 60:40 as training and testing sets respectively. And somatic cell count greater than 2 lakhs is considered as threshold. And in the attributes considered, somatic cell count greater than threshold is used as an output label with a value of 0 or 1 indicating whether the animal is affected by mastitis or not. The remaining attributes are considered as input parameters, and the training dataset is used to train k nearest neighbor and support vector machine learning algorithms. And evaluation of classification. The efficiency of classification models can be evaluated based on their performance using evaluation metrics. The most popular evaluation metrics used are accuracy, sensitivity, specificity, precision, and F1 score. Results, both SVM and KNN classifiers classified the results with an accuracy of 60%. The small data size consisting of only 55 samples results in less accuracy. Conclusion. The SVM and KNN classifiers used in the experiment with a 53 data set are able to classify the data for predicting mastitis in dairy animals with an accuracy of 60%. Due to the small sample data set, the accuracy of both models is not good. Machine learning algorithms yield better results when they are trained with large amount of data. This is an initial step. The future work envisages collecting field level data along with other details to be trained as per the proposed model to detect mastitis along with an advice to farmer. The authors are thankful to Velasco et al. For providing the data. These are the references. Thank you.
Thank you so much. Congratulations for your work. It's very good. At the moment, I'll start for questions. Do you have any questions? The listings? I have one.
Yes, sir.
And you put the architecture of the systems, please?
Yes, sir.
Okay, I waiting. Thank you.
Okay, Lakshita, I have a question.
Yes, sir.
You said that you are doing pre-processing of image. So is it part
yes,
of your
sir.
methodology? Then how are you doing pre-processing? Or which algorithms are you using, or have you developed your own methodology?
No, sir. I'm in the initial stage of my research. I'm planning to use pre-processing techniques like using filters, linear and non-linear filters for data cleaning, data validation. And this is a design of my architecture.
So because you are taking thermal images as well, so
Yes, sir.
accordingly you have to use filters.
Yes, sir.
Okay, fine. Thank you.
Okay, sir. Okay, sir.
Dr. Sastry, Gabriel, can we move to the next paper?
Sure, sir. Yes.
Yes, me. I don't finish my question. It's possible
Yes, sir.
finish and it left the okay.
Sir,
My
my PPT visible?
yes,
Yes.
yes,
Yeah.
yes. My questions the architecture of the systems and
Yes, sir.
why what the neural you use it's CNI or RNNI. Why? And I don't understand. It's the fuzzer rules do you use it? I don't know. Don't understand this part. The finish and the fuzzer rules with dominoes. Do you explanation for me again, please?
Sir, sorry, sir. I'm not getting you.
Could you repeat your question, Gabriel?
Okay. I don't understand. You possible put in the screen, please? Yes, okay. I repeat for you. The 30 point. The 30 point. I don't
Yes, sir.
understand. Yes. Do
This
you
one.
possible repeat again, please? Explanation for me. I don't understand. The
Third phase.
30 point. Okay.
Okay, third phase.
Yes, third part. Yes.
Yes.
Do you start the first rules if dominions? I don't understand. Do you possible
Okay, sir. Okay, we'll
explanation?
explain.
Thank you so much.
Okay. Okay, sir. We'll explain. Yes, sir. This is the phase 3. This is a phase 3 of my model. This model fine-tunes the classification of the machine learning model using domain heuristics stored in the form of fuzzy rules. That means if my model classified an image into mastitis, okay, it is having subclinical mastitis, but it is with very low temperature, then my model can give advice to farmers. Yes, your cow is having subclinical mastitis but with a very low temperature, and then advice to farmer is you just put some ice packs on udder as a home remedy. No need to worry. If your cow is having subclinical mastitis with a very high temperature, then advice to farmer is please immediately call doctor for your cow. Okay, like this we can have many home remedies and many more advices to farmer regarding this disease, which can alert the farmer even before it is going into clinical mastitis.
Okay. At the moment I understand. Sorry
Yes,
for you repeat. Thank you so
it's okay,
much.
sir. Thank you, sir.
Congratulations.
Okay, thank you, sir. Thank you.
Thank you. Next to work, professor.
Yes. Shall we move to the next paper? Dr. Sastry, do you have any question?
No, sir. I think we can go ahead.
Okay. Maureen, you have any question? You raise your hand. Maureen, do you want to ask the question, Maureen?
No, I think
Okay.
her hand is raised since her turn.
Yes. So we'll move to the next author, next paper, and paper ID
Can
is.
I stop sharing, sir?
Yes, sure.
Yes. Okay, sir. Thank you.
So next, Dr. Vasan, you may share your screen and start your presentation.
Yes, sir. Sir, I hope my screen is visible.
Yes, it's visible. Turn to the presentation mode. Yes.
Is that visible, sir?
Yes, everything is fine.
Okay, thank you. So I would be beginning. A very good afternoon to all distinguished panelists and participants. I, Dr. Ritika Vasan from Bharati Vidyapeeth's Institute of Computer Applications and Management, BVI CAM, New Delhi, shall now be presenting the preliminary work of my team of colleagues and students, which we have entitled as Enhanced Multi-Step Breast Cancer Prediction through Integrated Dimensionality Reduction and Support Vector Classification. The paper ID is paper ID 141. This would be the brief outline of the presentation that we'll be going on. Starting with cancer. Speaking about cancer, if we talk about cancer, cancer is a dreaded disease which can affect any body part. Breast cancer is a cancer type that is causing significant health alarm worldwide, especially distressing millions of women each year. Though it can affect males too, but one should note that it is 100 times more common in women, and it is a notable pathological condition with high mortality rates because especially in the developing nations, traditional machine learning models have been used for breast cancer detection as well as prediction since ages. But they face challenges with high dimensional as well as noisy data. So as breast cancer is one of among the most prominent cancer types among women globally, burden of the same is expected to increase each year in the Indian economy till 2025. As we can see in the figure below, as per Google Trends, the number of breast cancer cases being reported in the country during the last 5 years denotes a uniform pattern and a rise. However, the statistics are grim. There is hope as, according to the World Health Organization recent Global Breast Cancer Initiative Framework 2023, a roadmap should be enabled to save at least 2.5 million people from breast cancer by 2040. But this is keeping in mind the figure that over 2.3 million cases of breast cancer are detected annually worldwide. And along with this, over 80% deaths due to breast cancers are being recorded in low and middle income countries, that is developing nations, in which India also falls. A basic, I would say, silver lining at the end of this research is that it has been verified by numerous researchers that early diagnosis and prompt treatment can significantly increase a patient's chance of survival. Taking this as the cue, we have come to know that from our study, we have come to know that treatment have started within the initial 3 months of initial appearance increases the chances of survival of a patient. Breast cancer, if we talk about it, usually proliferates in the ductal region and lobules of the breast. The human breast is made up of lobules, connective tissues, and ducts. And breast cancer may originate either in the ducts, lobules, or may be indicated by either presence of a breast lump, enlargement, alteration in size, shape, dumpling redness, pitting, alterations in the presence of nipples or nipple discharge. Through this manuscript, we are aiming to propose an enhanced multi-step approach for breast cancer prediction by integrating dimensionality reduction, and that too, I would say, multi-step dimensionality reduction with the SVM classifier. This integrated approach will not only enhance the interpretability of the available data by identifying the most relevant features associated with the breast cancer, this shall further result in improving the prediction accuracy, and an accuracy of 96.5% was obtained on the initial studies which were carried out on the WDBC dataset as part of this work. Volumes of work related to breast cancer diagnosis and prediction have already been conducted. So before we started with the proposal, we first performed a detailed analysis of over 100 search works to understand the challenge to early accurate prediction. And considerable out of those 25 works have been discussed in this work of ours also. So our analysis revealed that most of the work have investigated the application of some dimensionality reduction technique for breast cancer prediction, but the impact on subsequently predictive models is missing. So we propose that if best correlated parameters can be chosen out of dimensionality reduction, breast cancer can be easily and accurately predicted through the machine learning models. Over here, we have a graphical representation of our basic research design. Our model works on predicting the likelihood of an individual having breast cancer based on the most correlated feature. So for that, we have used the standardized WDBC dataset. It consists of 11 features, out of which there are 10 nuclear features, and each nuclear feature is associated with 3 basic values, namely the mean, standard error, and the worst. So there are a total of 33 features we have among 569 patients, 699 patients, out of which 458 were benign and 241 were found out to be malignant. So in this particular data set, we have 2 basic classes as malignant and malign, and 11 integer value attribute. This is the basic data set schema that we have in this case. So this was followed by this input data set was first followed by pre-processing, where we applied handling of missing values and scaling in order to equate the complete data set. After that, it was followed by dimensionality reduction and feature extraction, because we realized that prediction quality of any particular machine learning model shall always vary according to the number of features that are being considered. So it requires generally, if there are n features, it requires n into d memory to store the particular data. So dimensionality reduction, as I would say all of us know, it is the mapping of data to a lower dimensional space to discard the uninformative variance in the same. So to improve the accurateness of the machine learning models, we first applied PCA after initial data pre-processing of our data, followed by EDA to reduce the dimensionality of the features to the level of 2 most correlated features. This helped to increase the efficiency of models with a faster rate. So that is how we proceeded further. First, we applied.
Dr. Vasan, sorry
yes,
for
sir.
interrupting.
Yes, sir.
Little bit fast.
Sure, sir.
Conclude in 3 minutes.
Sure, sir. So that was our basic hypothesis, that if the best correlated parameters can be chosen, then the breast cancer prediction can be accurately defined. So our goal was to find the best correlated dimensions that will accurately help in detecting breast cancer. So we performed PCA and we first achieved 13 basic attributes, which were the most correlated attributes out of the 33 dimensions that were taken. From those 13 attributes, we further performed EDA, exploratory data analysis, to finally come at 2 most correlated attributes, which were found out to be radius mean and texture mean. From these 2 correlated attributes, we applied 4 machine learning classifiers, namely logistic regression, decision tree, support vector classification, and random forest. To our surprise, support vector classification was found to have the maximum accuracy. These were our results. So concluding our complete work, from thorough analysis of the available literature, we finally concluded that if we want to ensure early and accurate breast cancer prediction, it could be achieved by integrating a multi-step dimensionality reduction involving PCA at the initial level, followed by EDA at a later stage. The final dimensions that could be obtained could then be coupled with the SVC classifier to obtain accurate breast cancer prediction model. And the results obtained have proved the same. But yes, the area for improvement remains. So at the moment, we have only tested this particular model on the standardized WBC dataset, which is, I would say, the standard dataset which has been used for breast cancer studies. But yes, we would like to expand this in the future by first integrating data. That means we would like to take in more real-time data sets in order to generalize this particular approach. Once this approach could be generalized, we would like to come up with a user interface where if a breast cancer is early identified for a given patient, personalized medicines, etc., can be worked out for the same. This may further lead to a new mechanism of feature interpretability, because this feature interpretability we have not seen as yet in any of the studies conducted previously up till now. We can also integrate this feature interpretability with the actual imaging data which is available for breast cancer prediction through mammographic studies, etc. Scope for continuous model improvements, yes, always remains, and support for translational research also remains, which is continuing as part of this study. So this is a basic reference to the overall work that we have presented as part of this work. So that was my basic presentation. I'm open to questions. So any questions?
Thank you so much. Congratulations for working. This is the good working because the health and the talk and the cancer. It's very important. For example, in my country, and always urge in the government investment the millions or billions dollars for the in the case and the good work. Congratulations.
Thank you, sir.
And don't have questions at the moment, Professor.
Okay.
Thank you.
Thank you, sir.
We'll move to the next paper, last paper, with paper ID 288. Abhida, are you the presenter?
Yes, sir.
So you can start your presentation. You can share your screen. And strictly follow the time deadline. So complete your presentation in 10 minutes.
Sir, my screen is visible?
Yes. Yes, turn to the presentation mode. Yes,
Is it okay?
everything is fine.
Good afternoon, everyone. I am Abira De from JIS Institute of Advanced Studies and Research, Kolkata. The title of my work is Investigating Natural Inhibitors of P-glycoprotein, PGP liver transporter via molecular docking simulation for hepatocellular carcinoma therapy. Now, the objective of this work is to identify novel natural compounds which are having the potential to modulate PGP activity, thus helping in hepatocellular carcinoma therapy. Now, human liver is the most important organ that is responsible for the elimination of drugs, and it is the connection between the gastrointestinal tract and the systemic circulation. So when a medicine is taken orally, they get absorbed by the intestine, but they have to go through the liver before entering the systemic blood circulation. Therefore, during this process, a fraction of drug enters the systemic circulation and the rest is eliminated, which may lead to a considerable influence on the bioavailability of the drug. Now, what are hepatic transporters? So before I talk about hepatic transporters, let me explain what are transporters in brief. Transporters are proteins that are responsible for transporting different materials like ions, molecules, and other macromolecules across the biological membrane of a living organism. Now, what is a hepatic transporter? Hepatic transporters are either lubricate the transport of nutrients inside the hepatocyte cell, And these kind of hepatic transporters are known as uptake transporters. And hepatic transporters also removes toxic chemical substances from the hepatocyte cell, and they are known as export transporters. Now, from this image, you can see that different hepatic transporters are responsible for the entry and exit of nutrients inside and outside the hepatocyte cell. The arrowheads are indicating which are acting as the uptake or the export transporter. So this is the PGP. Now the full form of PGP is permeability glycoprotein. It is a export transporter, and it's responsible and it regulates the elimination of the substrate drugs and drug metabolites from the liver into the bile canaliculi. Now, if someone is having hepatocellular carcinoma, then we give if we give an anticancerous drug that can inhibit the working of PGP, then the drug will remain inside the hepatocyte cell for longer period of time, and therefore in this manner the inhibition of PGP can help in hepatocellular carcinoma therapy. However, keeping a chemical drug substance for a longer period inside the body are associated with potential risks of toxicity, and therefore in this study we had aimed to identify some botanical compounds that can act as PGP inhibitors and help in hepatocellular carcinoma therapy using molecular docking approach. Now, what is molecular docking? Molecular docking is the process that involves packing of molecules in appropriate configurations to interact with the receptor. Now, in this cartoon diagram, it shows the importance of identifying the bound configuration. Now we need to find the configuration of the ligand molecule binding on the protein, and then we analyze how the ligand and receptor complex looks like. Now, docking can be of two types, rigid body docking and flexible docking. In rigid body docking, the protein molecule is considered to be rigid, and the ligand is only allowed to change its conformation and orientation to evaluate the binding pose and affinity. While in flexible docking, both the protein and the ligand molecules are allowed to undergo conformational flexibilities to produce a better protein ligand interaction. Now, in this study, we had used rigid body docking for our purpose. Now, this was the method of our work. So, first, we obtained the 3D structure of PGP from RCSB data bank. 6C0V was the PDB code. Then we found the anti-cancerous botanical compounds from literature. Then the selected compounds were docked against the PGP structure using Autodock Vina. Then the post-docking complex were analyzed, and finally we had we did the toxicity analysis for the selected compounds. Now, these are the 4 FDA-approved chemical inhibitors of PGP, which we had selected from literature. We had worked with these chemical compounds earlier, and we had a paper published regarding this work. Now, from this previous work, we observed that elaclidar and rosupridar had lowest binding energies with PGP, while quinidine and verapamil had highest binding energies for PGP. It is considered that binding energy is inversely proportional to binding affinity. Therefore, we can say that compounds having lower binding energy have greater binding affinity for PGP, and therefore they are considered as better inhibitors of PGP. Now, We then analyzed the binding energies of 156 botanical compounds, and we observed that these 7 botanical compounds were having comparable binding energies with that of the chemical compounds. Therefore, we can say that these botanical compounds possess high affinities for PGP and hold significant potential as potent PGP inhibitors. Now, we had studied the binding of elaclidar and zosuquidar on the active site cavity of PGP. In the figure, in the 3D figure, you can see that the two compounds had bound exactly at the binding site of the PGP protein. This is indicating that they are acting as good inhibitors, means they have interacted well with the PGP, and they are therefore acting as good inhibitors of PGP. Here we had analyzed the binding of quinidine and verapamil at the active site cavity of PGP. From this 3D figure, that you can see that the compounds had not bound exactly at the active site cavity, and thus indicating that their interaction is not that good, and they are not that good inhibitors of PGP. Now, we had analyzed, we had taken 2 botanical compounds for analysis of this structure, and those are diosmin and camphorol, and we can see that diosmin and camphorol both bound exactly at the binding site cavity of
Abira, you may continue. We cannot hear you. Abira, are you there? Maybe some tech. Just a minute. Yes, Abira. Please
yeah,
continue.
somehow I got disconnected. Please
Yes, I
make
think
me
there
the
is
presenter.
some like a technical issue.
Yeah, please make me the presenter again.
Yes, you are presenter.
Sorry, sir, I can't.
You can't. Just a minute. You are presented now.
Yeah.
Just conclude in 3 minutes.
Yeah, sure, sir.
Yes.
Yeah, now you can see my screen.
Yes.
So I was saying that we had analyzed the binding of 2 botanical compounds, diosmin and camphorol, on the active site cavity of PGP, and the figure is also showing that the binding is exactly like those in the good inhibitors of good chemical inhibitors of PGP, as you can see here. The activity, the binding is same in this part. So we had then finally we did the toxicity analysis. We analyzed, we used Vega Hub computational toxicity analysis tool for this purpose. So we observed that diosmin exhibited lesser toxicity compared to the chemical compounds. but we didn't got actually time for analyzing all the 7 botanical compounds. And also please note that these are computational toxicity based approach, and we need to further validate this analysis by dose based and in vitro toxicity validation. Now in conclusions, I can say that PGP plays important role in the flow of bile acid from hepatocyte cell into the bile canaliculi. And if the working of PGP is inhibited by some drugs, then it will remain inside the cancerous liver for a longer period of time, and this can help in hepatocellular carcinoma therapy. But keeping a chemical drug substance for a longer period inside the body are associated with high potential risks of toxicity. Therefore, in this study, we aimed to identify some botanical compounds that can act as PGP inhibitors and help in hepatocellular carcinoma therapy. We observed that 7 botanical compounds exhibited binding affinities for PGP that are comparable to those of the chemical compounds. Therefore, we can say that botanical compounds possess high affinities for PGP and can hold significant potential as potent PGP inhibitors. We also observed that botanical compounds possessed lesser toxicity as compared to chemical compounds. Thus, we can say that plant-derived anticancerous compounds can act as potential substitutes for synthetic PGP inhibitors and help in hepatocellular carcinoma therapy. Now, I would like to thank Moldog Biotech Private Limited for letting me work on this project inside Biosolutions France, and University of Health Sciences Turkey for providing all the support, and also this conference for letting me present my work. Thank you so much.
Yes, any question?
Congratulations, thank you so much. And I have one question. Your explanations, the future work, do you possible explanation, please? The future work, your imaginations.
Oh, okay. Future of work of this particular project, right?
Perfect. And you implement the particle and the for new treatment. Yes.
Sorry, sir, I can't understand you.
Do you talk on the implementation new treatment for future work? Okay.
So, sir, for future work, we are planning to go for the wet lab analysis, and also we need to analyze all the 7 botanical compounds first. Then we, after the toxicity analysis from computational approach, we will think of if we'll work with all the 7 or we'll reduce from we'll reduce the list or not. Then we'll also see that these compounds are only inhibitors of PGP or also inhibitors of some other hepatic transporter. Means if if you see in this image, if it inhibits some other transporters as well, so it will lead to accumulation of bile acid inside the liver. It will then it will lead to liver damage also. So we need to check whether this are only inhibitors of PGP or all the hepatic transporters. If that, then we have to exclude those compounds. In this process, we need to work in future, and yeah, we have lot of work to do.
Okay. Congratulations. Thank you for explanations.
Yeah.
Thank you.
Thank you, Abira.
Thank you,
Dr.
sir.
Sastry, do you have any question?
No, sir. I think the work is very good, completely
Okay. So
and
can we
thoughtful, sir.
conclude this
So I'm
session?
congratulating, sir.
May I stop sharing, sir?
Yes, you can share. You can stop.
Yeah, thank you, sir.
So there is no more paper in this session. So if you would like to conclude the session, Dr. Sastry and Gabriel, then you may
Yeah, sure.
conclude.
Yeah, I think thank you so much, Dr. Patel, for this opportunity to chair. Sorry, to chair a session. I mean, the works were really good. Specifically, there were many works related to my domain also. Cancer classification and learning, machine learning. So I really enjoyed all the works, and I congratulate all the speakers and all the participants for getting their paper published here in this conference, and all the best for their future.
Thank you. Gabriel?
Thank you so much. Firstly, thanks so much for organization, Professor Patel. Congratulations for excellent conference. It's one privilege for me. Participations every years for helping. Thank you so much. And the congratulations authors. It's the biggest, the articles, the have much informations. Congratulations, good work.
Thank you, Gabriel. So we'll close here the session, and we complete the day one of this conference. So thank you very much, all of the participants, to remain present here in this session. We'll meet tomorrow at 10 o'clock in the morning. So everyone, bye everyone.
Bye. Thank you.
Bye bye. Thank you.
Ada દિવસ પૂરો. Find out the